Welcome to APEC Open Mic. It's October 14th, and I am your moderator, Tim Ventura. I want to give a big thank you to everybody joining us on this call, along with everybody watching us on YouTube. So as a reminder, today's session is for open discussion and ad hoc presentations. We don't have anything scheduled in advance, but we do have a couple of attendees who have reached out and asked to present. Bill Alek is one of them, and I've had a couple other folks who have asked as well. So I am excited to get them started, but I do want to start out with a couple of quick reminders, and today we got a little bit of show and tell also. Okay, so quick reminders: you can view conference replays, details, and speaker info on our website at altpropulsion.com. I'm going to show you some updates to that in just a moment. I'm really excited about that. During the ad hoc presentations, try and save your questions for after the presenter finishes, if possible. You can raise your hand in Zoom. We are using Zoom today. It's Option Y on Mac or Alt Y on Windows. Again, open mic is a little bit more mellow. It's a little bit more casual. This is not as structured as our webinars. And we do that on purpose, right? So that people can share and present without feeling the pressure, I guess, that comes along with that structured presentation environment. We wanted to have kind of both types. So this used to be the open discussion. For anybody who isn't sure, we used to have a lengthy open discussion after each webinar. We split those up, right? And that's why it starts later. We're starting these at 4 p.m. Pacific. That's when we used to start the open discussions. So you can type your questions into chat. Again, raise your hand in Option Y on Mac or Alt Y on Windows. We're not going to be firm on hand raising during open mic unless things get chaotic. So let me encourage you to jump into the discussion when it feels appropriate. Again, try not to interrupt the presenters, but jump in when there's open discussion going on. Also, try and keep things focused on the core topics of the alt propulsion community. So we do have a couple of ad hoc presentations today. Bill Alek is the first, and I am not sure if he is here. We have all of the, I'm just looking at our Zoom session here. We've got all the usual suspects with us, but before we get into that, I am super excited. I'm going to do a screen share and share our latest disasters. Okay, so for anybody who hasn't seen it, this is the new Falcon Space website. This is Mark Sokol's group. Mark is working on dynamic nuclear orientation. And he actually has built prototypes for, I mean, he's done superconductors. He has done inertial propulsion devices. I understand that he's going to be doing some more with Ted Pittman in the near future. So Mark he is involved with everything. He is just building stuff left, right, and center. I'm really excited about that. We just got the Falcon Space site updated for him. This is just a simple one-page site, and we might do some more on this in the future. These are all of the different channels that Falcon Space has been mentioned on, including our very own APEC conference. So this is Falcon Space. Check it out. It is at falconspace.org up here in the URL bar, and show him a little bit of love. And he has also got a presentation here, basically an overview of DNO and the alciphon, which all of you are probably very familiar with at this point. So these are just basically some of the things that he's worked on. Also, we have a very nice picture gallery. He sent me over 2,000 photos. So I just wanted to share some of these with you. Again, tremendously busy and active. So I am so pleased to be able to get this out there, as well as some of the folks who have contributed directly to the Falcon Space project, although I know many, many of you have had input. So that's Falcon Space. The other thing I want to share with you is updates to our very own APEC website. I basically just got busy. I was working on Falcon Space, got motivated and said, you know what, we can do a little bit more with APEC, and I'm going to continue to update this in the future. So new buttons on the homepage. Again, some of the various places that we have been mentioned. I also focused it a little bit more so that you guys would be able to see what's coming up right when you're there, like right when you hit that main page. optical unification, let me see, SQK, and the Mega Drive and SEG. We have a lot coming up for October 28th. Again, that is our structured webinar presentation. And then just some gimmicks and gotchas. So the other thing that is worth keeping an eye on is, well, number one, discussion and chat forums. Probably most of you guys are in the APEC 24/7. Those are WhatsApp groups. Mark Sokol just did some updates on those. He added them to a community. The other thing that we have is Talk, which is a more traditional message forum. That's a paid forum. So that's something that we put there for you guys to use to communicate. And Todd has been really big on keeping that up. We do have a conference schedule here. And if you click on that, you can add these to your calendar. And the other place you'll find that is schedule and format. And I am keeping these updated. So you can go in here. The only thing to be aware of is this APEC webinar. These are placeholders. And as you can see, the actual event is there. But the reason I did this is we only know a month or two in advance what these are going to be. So I wanted to have all of them marked out so that you guys would know what the dates are, even if we don't have it scheduled. So that is what I have to share. Oh, one more quick thing, I guess. So I'm adding the open mic and the regular conferences to the main page. If you're not sure, Linktree here has links to all of our channels, including like APEC 24/7 and the Talk. So, so that is worth checking out. So again, that's altpropulsion.com, and check out falconspace.org also. Okay, so I'm going to stop share, and I'm going to remove Spotlight from myself. And I think Bill Alek is with us. Okay, let's see if Bill is here. Nope, Bill is not.
Tim?
Yeah, you are here.
Can you hear me okay?
I can now.
Great.
Bill, do you want to do a presentation for us?
Yeah,
Okay.
I finally got one together here. And
Let
a
me
few
hand
weeks
things
ago.
Let me hand things over to you, and you're the man, okay? I'll disappear into the woodwork for a while.
Okay, so what do I do here? Share screen?
Yeah.
I click on that. Okay. Let's see, how do I start this up? Just bear with me here.
I've already told everyone in my life that I will be in Zoom until the wee hours of the morning. I'm fully stocked with Red Bull and coffee. So
okay. Yeah, I got my coffee cup here as well.
Oh, and Andrew, let me see. Andrew's chatting and said, okay, and Andrew has some updates on quantum interactions too.
Okay.
Andrew, if it's okay, is it okay if you go after Bill?
Yeah, man, sure. It's your show. If you got a few minutes, I think this just might be interesting to somebody.
Oh yeah, no, you're doing wonderful stuff. There's an upside and a downside to not having things scheduled. The upside is it's less pressure, right? It's more like we originally started with, but then the downside is it's kind of managed chaos. Sometimes I worry about looking like an idiot, but I look like an idiot either way, so that's not that much of a trouble. Okay, Bill, let me see, sir.
Yeah, I'm working on this share.
There we go. So okay. Yes, I see it, and it looks
you got
wonderful,
it there.
Sir. Replicating
Now,
Tom Bearden's scalar wave.
Right. Yeah, this has been my real focus is giving these presentations here about the past year or so. And I really collected all of Tom Bearden's material here, a lot of his video information, and you know, even attending some of his conferences back then, 20 years ago. And I really found the time here to put all this together for the audience here. Okay, let me go from the beginning. Okay, there we go. Can everyone see this? Can you see this okay?
Yeah, I can see that. You know, Bill, I should before you really get started, I should mention David Chester was going through equations the other day and got really excited about Tom Bearden, which is
Right.
interesting because he did a full circle. He looped back around from mainstream conventional physics. He came completely different focus. And he came back and he said, maybe this explains Tom Bearden. And I was like, there you go. So
yeah, there you go. Yeah, well, Tom Bearden's unique in this field. I mean, you know, when I went to his conference back in, '97, you know, I heard about it on Art Bell, you know, the Art Bell show, and Coast to Coast. And he had Richard Hoagland on his show, and he was talking about Tom Bearden. I was wondering, who is this guy? And Tom Bearden was presenting his scalar wave technology. And the title of the conference was Free Energy and Anti-Gravity. Well, naturally, that caught my interest. And that's because back in 1977 here, let me go to my first frame. Let's see. Okay, 1977. I was attending IIT Engineering School in Chicago. And I had this vision, this lucid dream. And it was just incredible. I never saw anything like this before. And I was constructing an anti-gravity disk. And it's like, oh my God, this is incredible. How does it work? Well, as time goes on here, I started to fill in some of the blanks. And so I attended this Tom Bearden conference back in '97. Just to go back to '79 here, I graduated with the BSEE degree and began my professional career. Okay, working with electronics, writing software. I worked for a lot of the major corporations like Motorola, Hamilton Sunstrand, all the big names, working on all the big projects out there. Okay. And so I did that for 20 or 30 years here. Okay. And then this Tom Bearden's conference came along where he spoke about free energy and anti-gravity. I said, oh my God, is this vision that I had back in '77 starting to come together? And it seems so. And so I attended this conference and I was just blown away by it. And you think listening to Tom Bearden that you can, great, you know, I can go out and build a free energy device. Well, it took a number of years to be able to actually do that. You know, because the thing is, see, the thing about Tom is that he wanted a big DARPA contract. Okay. So some of his stuff, you know, he held back on some of his information, but he was very good in presenting a lot of material, but he held back on certain things. Okay. And that's when I'm going to fill in the blanks. Okay. With Tom Bearden on tonight's lecture here. I'm going to fill in, I hope, a lot of the things that Tom did not include in his lecture, and give the audience out here a complete picture, a complete model of what Tom was speaking about or what he spoke about, you know, in his lecture. So really in 2022 is when I started putting it all together, okay, and started lecturing about Tom's technology. So the next slide, Tom Bearden quotes, and he mentioned this in a number of his lectures, that all matter is made of trapped electromagnetic energy. Okay. And, you know, in a way that's true, because you'll see in quantum field theory that this is absolutely true because of certain things, certain mathematical operations that pop up. Okay. But we'll get into that a little later here. And the other thing that Tom spoke about was that we can't see the dimension of time, but we know that time exists because of spatial displacement. It's the fourth dimension. And you can't see that dimension. Okay, we can only see in 3 dimensions here. But we know time exists because of this spatial displacement. So next slide. The electric force versus the gravitational force. And this is where I ran through all the numbers. And you'll notice the electric force, when compared with the gravitational force, well, look at that number, 10 to the 42nd power, okay? That the electric force is that much stronger than the gravitational force. God, 10 with 42 zeros after that. I mean, it's gigantic. But keep in mind that it's not 0, okay? It's not 0, and that's very important, okay? So we're dealing with something that's incredibly small, the gravitational force. So next slide. Now, is there a link between electromagnetism and gravity and anti-gravity? Well, Tom put up this slide. I thought it was rather intriguing here. The electric field is, of course, a transverse field. The magnetic field is also transverse as well. Okay, and this is what we see on our oscilloscopes. Okay. Now, the 2 fields below that are what we call scalar fields, or what Tom referred to as a scalar field. And it's all omnidirectional, okay? It's a longitudinal field. And we see that the gravity field, okay, is like an electron, and impinging upon that electron is this scalar field that's longitudinal. And I like to say that, a gravity field is time, okay? Time is gravity, gravity is time, okay? And so we see these 2 longitudinal fields. One is gravitic, and the other one is anti-gravitic, okay? And we'll get into this anti-gravitic field a little later on in the slideshow here. But it's interesting that it affects time, okay? Because time is also a scalar quantity. Mass is scalar, okay? So let's go on to the next slide here. So keep these 2 in mind here. Einstein's unified field theory. Well, he failed at it, okay? And Tom Bearden spoke about this as well. He spent the rest of his life trying to find a connection between, the scalar fields and electromagnetism, okay? But he failed at it, okay? His unified field theory was a complete failure, okay? Next slide. Modern science discovered this connection, and yes, we call it scalar waves. Next slide. Tom Bearden's scalar waves. They are best described as anti-gravitational waves that have the properties of being both time-reversed and longitudinal, okay? So keep that previous slide in mind that, a scalar function is longitudinal, okay? Next slide, how to produce scalar waves, okay? Well, in this case here, what Tom and other inventors as well, like Stanley Myers, Floyd Sweet, you can go to Rex Research. I think maybe that website is still up. A lot of this information may still be there, okay? But the bottom line here is that we're taking the cross product of 2 vectors, okay? 2 vectors in opposite directions. They're equal in magnitude, but opposite in direction. We call those equilibrant vectors, which produce something called a 0 vector, okay? You also want to keep that in mind as well, the 0 vector. And the system must be operated in resonance for the scalar term to appear. Okay. Next slide. Tom spoke about, there's a couple of different types of scalar waves, okay, that are produced here. One is a time-reversed EM transverse wave, and that's what we see on our oscilloscopes, okay? Time-reversed EM transverse wave. The second kind of wave we have here is a time-reversed gravity or anti-gravitational wave, okay? Now in gravity, it's time forward, but in anti-gravity, it's time reversed, okay? Next slide. Okay, now this is something that Tom discovered, scalar quaternion solutions, okay? And this is really Tom Bearden's scalar wave theory, okay? And you'll notice at the top there, the vector solution, which is the Heaviside Maxwell electromagnetics. This is where Heaviside came along, you know, after Maxwell wrote down his, 20 equations or 20 unknowns, I think, and using his type of mechanics, his quaternion mechanics here. What we're doing here is that we're taking the cross product of two opposing waves. Now, Heaviside solution to this problem is that we take the cross product of these two opposing waves and we end up with a zero vector. Well, guess what? That zero vector is empty, okay? This is really the failure of mainstream science. What we have today is a failed science, okay? And this is where Heaviside came along and simplified the Maxwell quaternion solution, okay, to electromagnetics. But now we have to go back to find the correct model here, okay, because we're dealing with a zero vector that's empty, okay? But the quaternion solution, the zero vector is not empty, okay? That's because it has this a squared term, okay, built into the electromagnetics. And we see that when we take the cross product of these two opposing vectors. We see that we have a scalar entity that's there, okay? And that again is very important because this is what we see on our oscilloscopes is this scalar entity, okay? So as we go on here with the solution, you know, you just substitute in with this equation here, the two sine waves, okay, that the opposing vectors here are generating two sine waves in equal and opposite direction, okay? And when you plug them into this equation, you see that you have the a squared term times sine squared omega t plus the zero vector, okay? And this is what Tom Bearden really identified, you know, in his presentations. You can go back, you know, I put references in with this presentation here, so you can go back and look at these videos as well. And he calls this zero vector a vacuum engine, okay? Because inside of this engine, we have this scalar anti-gravitational longitudinal wave that's also produced. So we not only see on our oscilloscopes the scalar wave, the sine squared term, but we also have an anti-gravitational longitudinal wave, okay, coming out of this device, okay? And it's inside that zero vector. So, so what we end up with is, of course, the sine squared term, which is electromagnetism time reversed transverse wave function, okay? And that's really the zero vector vacuum engine is what produces this anti-gravitational longitudinal wave, okay? Next slide. Oliver Heaviside simplified the Maxwell equations back in the 1880s. And he made this interesting comment, okay, when he did this. So in regards to the scalar component, he regarded this as mystical and should be murdered from the theory. Tom Bearden says Oliver Heaviside threw the baby out with the bathwater. Okay. And what I say is that this is the main reason why we don't have Star Trek today. We should have had it decades ago, literally decades. Okay. We should have had Star Trek decades ago. So next slide. How to determine resonance? Well, for example, here using my split flux transformer, which I'll get into a little detail a little later on here, we see the output. And the output is designed to eliminate the magnetic motive forces. Okay, it's designed to really eliminate the magnetic field. Okay, that's in opposing directions here that you create using two sine waves feeding this device. And you operate this device in resonance, okay, which means that you have a capacitor output and a resistive load as an output as well. And so what we see on our oscilloscopes here is that as you adjust the frequency of this device, you have a resonance point that is a minimum resonance, okay? And at minimum resonance is where we start to see the scalar function, okay? And this is very important as well, because when you have balanced coils, now I don't have balanced coils in my SFT, they're not balanced at all, but okay, Stanley Myers came up with a method by which you can tune the coils to balance them properly, because you want to eliminate as much as possible the magnetic component of this, okay? This, of course, drives the current to near zero. And this is what Floyd Sweet did, you know, with his technology, okay? Because the objective is to get that current as low as possible. And when you do that, when you do the calculations for the COP, guess what? 100% is no longer a barrier, okay? Your technology can go way over 100%, okay, when you do these calculations for the coefficient of performance of your device, okay? So you're looking at input and output when you compute the efficiency of your system here. And when you do so, you want to drive I minimum as low as possible. And you do that by setting up balanced coils, okay? And so Floyd Sweet was able to do that. He spoke about 10 million% efficiency, okay, which is astonishing. And his device lost something like 90% of its weight, okay? The mass acceleration effect changes with these devices. And so you have this scalar wave, okay, that's being produced. That's not only longitudinal, okay, but it's also, you see it on your scopes as transverse EM waves as well, okay? So we're creating what's called a pumping action at resonance, which creates your phase conjugate mirror. And it's like, wait a minute, phase conjugate mirror, that's something that you have in optics. Well, yeah, so you work with electromagnetics, okay, in the optical range. Well, guess what? You can do this at very low frequencies, okay? And this is what Tom and a lot of these other researchers have done, Floyd Sweet, Stanley Myers, you know, they all run their technology at very low frequencies, okay? So next slide. PCM resonators, okay, because this is what we're building, okay? When we set up, for example, here, my split flux transformer, you see two opposing coils there, and an input coil. And this is what really creates your opposing magnetic forces, okay? And you resonate that with the capacitor output, okay? And so I ended up filing a patent on this back in 2020. Tom Bearden lectured on this subject back in the 1990s. And it's called a pumped phase conjugate mirror, okay? That's what we're doing. Next slide. PCM resonators. Output's a time-reversed transverse EM wave. The output becomes more efficient, okay? Your output becomes more efficient, and efficiencies can exceed 100%. You no longer have the 100% barrier, okay, that we have in virtually all our supplies. Okay, so if you have a single coil on your output, your maximum efficiency might be like 98%, you know, on that order. A transformer is between like 70 to maybe 85% efficient, you know, that sort of thing. And so the device outputs an anti-gravitational wave. It decreases its own mass acceleration effect. So the weight can become negative or less than 0, okay? So next slide. Examples of PCM resonators. You know, my split flux transformer. Nikola Tesla's magnifying transmitter. Believe it or not, Tesla got into this as well, okay? With this magnifying transmitter. It's probably his original patent. Which I'll get into here a little later. Stanley Meyer's water card, metamaterial resonators, okay, also produce this effect as well, okay. David Perez was I think getting into metamaterial resonators as well, okay. Next slide. Okay, my split flux transformer. This is the whole deal here. Okay, what you're looking at is an electrical schematic of what this device, what it is, okay? So you have a primary AC source, and that splits the flux with L2 and L3, okay? And that sets up your opposing magnetic forces here. The idea is to cancel. You want to fully cancel your magnetic component. Okay, because that's what drives your efficiency up, okay? And so that output drives a capacitor and a load resistor, okay? That's all there is to it. That's it. I have a patent was granted. I filed it back in 2015. It was granted, I think, during the Trump administration here, okay? So next slide. PCM resonators. Now, this is a Tom Bearden slide here, okay? But he didn't really go into detail. You know, again, Tom wanted that big DARPA contract, okay? Never happened. Never happened with Tom. So anyway, I kind of filled in the blanks here, okay? So some of the missing pieces. So we have our pump waves, wave 1 and wave 2. Setting up, and you want to get those in phase with one another, okay? They want to be in perfect phase. So your wave functions here, they generate W3, okay? It takes the product of wave 1 and wave 2, and you get this, this weird sine squared term. Okay, and I call it weird because when you look at it on the oscilloscope, yeah, it's kind of a weird looking shape, but we'll get into that, okay? And then the output of this device, W4, is your magnified output, okay? It's time reversed. And how do you know it's time reversed? Well, it's more efficient, and then your output, your efficiency goes up, okay? So it's a time reverse transverse EM wave that comes out, and W5 is your time reverse longitudinal component, okay? And again, I like to say gravity is time, time is gravity. So if it affects the rate of time on your watch, okay, or on crystal oscillators, okay, this type of wave, and you'll see the wave function go down, okay, your wave will start to decrease, or maybe the wave function will start to increase. Okay, it depends upon your term here, this anti-gravitic term, okay, which subtracts time. Okay, next wave, the output wave function, time reversed transverse EM wave. So this is what we see on our oscilloscope, as I mentioned before, our sine squared term, and that outputs a magnified sine squared output term. Okay, and there's some of the mathematics behind that. Okay, the history of opposing magnetomotive devices, and I included Tesla in here, and I see that he had 2 coils on his output, and so you could run those coils in the opposing magnetic direction here. And you can look up his patent. There's his patent number, filed back in 1896. Okay. And this is a schematic that I put together of Nikola Tesla magnifying generator, and it shows the opposing coil configuration. And again, you want to eliminate as much as possible the magnetic component of this. And so when you think about that for a second, isn't that what Tim Ventura did, with his lifter technology? Isn't it like entirely electrostatic? Okay, maybe. So Tesla did this back in 1896. This is a schematic I came up with. Okay, this is Stanley Myers. This is right out of his patent, okay? And so he connected the output of these 2 coils that set up this opposing magnetic field component here. And the output drove what he called a water fuel cell, okay, which is a couple of plates, and using as a dielectric his water fuel cell, okay. And Stanley's objective is to make this hydroxy fuel, okay? But he does it very efficiently. He was claiming something like 1,200% efficiency. And I know Max Miller, you can look this up, about maybe 5 years ago, did a brilliant presentation on Tesla Tech. Okay, and the video is available from Steve Ellswick there, on replicating Stanley Myers' technology. And that's exactly what Max Miller did. Okay, and he observed this ultra high efficiency driving these water capacitors, okay, and making this hydroxy fuel, okay, and we'll get into that here too as well. Next slide. Okay, this is, I did some analysis on what Stanley was doing, setting up his opposing flux, opposing magnetomotive forces in his device, driving this water fuel cell, or this water capacitor, okay? Next slide. So what is this water fuel? Okay, it's also known as hydroxy gas. It's oxyhydrogen gas, known by these different names, HHO gas, electrically expanded water, or Brown's gas. Yul Brown did a lot of research, okay, with this HHO gas. It's highly flammable, okay? This gas is highly flammable, and and when it burns water, okay? Your exhaust is water. So the gas, what you find out here is that the gas burns cold. It doesn't burn hot, okay? So we see these low temperatures, 266 degrees Fahrenheit, 130 degrees centigrade. But it will vaporize tungsten. Okay, so that means that the flame is highly electrical. Okay, when that gas recombines into water, okay, it's highly electrical and it will vaporize tungsten, believe it or not. So made using multi-plate electrolyzer using a DC voltage and current. Okay, but it has to be this pulse current, because of course, in all transformer designs here, you have to have a changing flux to produce your voltage. Okay, so the objective here is to burn water, not gasoline. Okay, burn water, not gasoline. So that's what we want to do here. And Maury King wrote a book on the subject. There's the ISBN number. You can look it up, and it's called The Key to New Energy. Okay, so the objective here is to burn water, not gasoline. Next slide. What is water fuel? Well, this is how you make it. Okay, you could use a conventional power supply. Okay, and it's like 12 volt DC output and 30 amps. Oh, that's a pretty hefty current here, driving this water torch. Okay, you could buy this online. Okay, I have one here. And what you have to do with this, though, is that you have to mix the water with a catalyst. Okay, you have to mix it with a catalyst to get it to separate properly into this HHO gas. And that's what you burn here, okay, with this water torch. So the next slide. Okay, now, relativistic quantum field theory. This video, for some bizarre reason, was taken down. I can't explain why, but it answers this question of what is a particle, okay, in quantum field theory. And when I saw this, I was stunned. Okay, I was absolutely stunned when I saw this, because there's your frequency minimum squared term, okay, as your wave function. And when I saw this, there it is. There's your scalar wave term, okay? And what did Tom Bearden say? Well, he said all matter is made of trapped electromagnetic energy. And so there it is, folks. There it is. Your massless particles are, of course, photons, no mass at all. But when you look at the left side here, particles with mass, what's creating that mass? Okay, is this scalar wave function. All right, you have two trapped photons, for example, spinning together, okay, creating a scalar function. And when it does so, you see that it has this cross product associated with it, okay? And these two frequencies, your sine squared term is right there, okay? Next slide. The scalar wave test bench. This is my test bench. You'll see on the right here a power supply, nice power supply, GW Instec. I recommend these power supplies. You get a full range of voltages, currents, AC, DC. They're incredible power supplies. I love them. And then you have in the center here your oscilloscope. And you'll see on that oscilloscope that funny looking waveform at the top there. It's a blue trace, okay? And that blue trace is your sine squared term added to your input sine wave, okay? So it's really a complex waveform of two waves, your scalar function, sine squared term, and your sine input form, okay? And the two get added together. All right. And that's what we see on the output of this split flux transformer. And there's the transformer. It's for real. And I wrote some software. Okay, and this software, you can actually download the software. It's on my website. And it works with this particular model scope. And what's nice about this scope, and I think it's still available from Newark Electronics, and maybe some other suppliers as well. And the scope, it's isolated channel. That's what you want to use, isolated channel. So then you can hook up your meters on here, okay, to read the currents. The scope will read the voltages, okay? And the software that I wrote interrogates the scope, okay? It has a serial channel on the back, and it's a USB to serial. You know, the scope still uses a serial channel of all things, okay? But the point is that the software interrogates the scope, gets all your phase relationships, does all these computations, okay? And the objective is to compute the efficiency, okay, of your system here. So the next slide. This is some MathCAD modeling I did. You know, I still have an old XP system and all my old software that runs on here, but it runs great, all right? I saw no need to upgrade and spend all that money because this software works perfectly well. And so this old version of MathCAD, okay, has your sine wave input, your scalar wave term, okay? And then when you add the two, all right, your input wave and scalar wave, when you add the two, you start to get this funny looking shape, okay? Next slide. And this is what we actually see on our scope. And there it is, lo and behold, you see the input current, the sine wave input current term. We're measuring current here. And the sine squared, the scalar term, okay, the scalar wave term. This is the electromagnetic term, okay? And so we see this funny looking wave shape. Next slide, determining transformer efficiency using AC circuit analysis. This is all the number crunching, okay, that I do in my software. So we're looking at all these phase angles, input and output currents and voltages, computing the COP of the system, and ultimately getting the efficiency of the output. Okay, so that's the objective. Next slide. This is my software. I added more to this software that integrates into the power supply. Okay, but the point here is to show the transformer efficiency, and you'll see that the transformer's efficiency goes up. Okay, it goes up. And so that's how you know the signal's time reversed as well, because your efficiency will go up. Okay, now my issue here is that the coils are not balanced. You know, I don't have anything that will balance these coils. So it's just a raw output. And so we see this increase in transformer efficiency. Okay. And so this is all the data, okay, that reads this oscilloscope. It's shown on the right side of channel 1 and channel 2 and channel 3 and channel 4. So those are your voltages and currents. And so we look at input voltage and output voltage and do all this number crunching. Okay. Next slide. These are all the calculations I perform, okay, with this device. So you see the apparent power, real power, reactive power, does all this crunching, computes the phase angles, and does all this wonderful math, okay? And ultimately it ends up with efficiency. And so here's a bunch of captured screens I have here. Various screens of the transformer inputs and outputs. Next slide. All right, so as I mentioned before, Tom's military applications revealed. Okay. Now, Tom spoke about this in his lectures. He called it scalar wave interferometry. Defense application requires 2 ground-based scalar wave emitters. Tom spoke about that as well. Okay. And it's the region where these 2 beams, you have 2 scalar wave generators emitting high frequency, okay, and where these beams cross creates a zone of a strong electromagnetic field, okay, and that field is capable of destroying electronics within that target zone. That's pretty cool, isn't it? Pretty neat stuff. And so Tom wanted a big DARPA contract, okay, never happened. But that's what he was after. So he left, some of this information out. I'm filling in the blanks here. Okay. Next step. Next slide. Scalar wave interferometry. Okay. So this is what happens when you start playing with phase relationships. Okay, with your signals. You can either create electromagnetic virtual ground in that region of space, or you can create a strong AC potential. Okay, that can fry your electronics, okay, in whatever target. It could be a satellite, a plane, whatever, okay. Next slide, scalar wave interferometry. This was a slide that was very similar to what Tom was doing. And this is what happens when you set up either a virtual ground or a strong AC potential, okay, in that region of space. So that's your target, okay. Next slide. All right. Well, this is cool. David Scott, astronaut David Scott, back in 1971, did a replication of Galileo's experiment, his drop experiment. And he used a hammer and a feather. Okay. And we all saw that. Okay. We saw that on television. And it's on video. You can look this up on YouTube. David Scott conducted Galileo's famous experiment where he drops a hammer and a feather, and they fall at the same rate on the moon. Okay, the moon, of course, has a hard vacuum, very hard. And of course, it was Apollo 15. He did this cool test with a hammer and a feather, and they fell at the same rate. Well, then I ask you, what is the exception to this rule? And believe me, yes, there are exceptions, all right? And we're going to get into that now. Next slide. The Boyd-Bushman experiment, okay? The Boyd-Bushman experiment. He did a drop test as well, except his drop test involved magnets, okay? And he set up these magnets in opposing configuration. That's very important. Again, you're canceling out your magnetic component, okay? Well, we saw that with the SFT, my split flux transformer. We saw that with Stanley Myers, with Floyd Sweet's technology. Tesla did this. The idea is that you want to cancel out the magnetic component. So really, you have a voltage, okay? You just have a voltage here. And the idea is to create an opposing magnets here, okay, that affect the mass acceleration effect. And that's exactly what Boyd did. Now, David Sereda made this video. He videotaped Boyd, okay, not doing the test, but the results of the test. So I said, well, okay, this is something that I can do. Okay, I can do this test. You can do this test. Okay, you can do this test at home, maybe. I did it in Sedona over there at the Creative Life Center. Okay, and we're going to get to that in a few minutes here. But the point of this video segment here about Boyd Bushman, he's a Lockheed Skunk Works, I think, weapons developer. okay, a very bright guy. And so he devised this experiment using magnets in the opposing configuration. Okay, next slide. Okay, and I call this the Bushman-Alek drop test. And you see here, I did this at the Sedona Creative Life Center. I videotaped this, okay? And it was from a height of almost 30 feet, or almost 9 meters, okay? So what did I do? Okay, well, you got to force these magnets together, you know, and as Boyd Bushman said, they're very dangerous, you know, when you work with neodymium magnets. The field is extremely powerful, okay? They can slip on you, flip, and then clunk together, and you do not want your hands in between those, okay? I guarantee you, you'll have a problem if you do. So what I did is that I epoxied them together, okay? So this is my little jig here for forcing these magnets together. You can do this as well. There's the jig here, neodymium magnets with the epoxy, okay? The two magnets forced together. And there's the test, well, there's the jig there. And down there at the bottom, you see the magnets epoxy together, and epoxy works great, okay? You can even use this epoxy on very large, 6-inch diameter neodymium magnets. That'll scare the hell out of you, you know, if you work with that. But the epoxy will work great, okay? So this is, it shows the two magnets here with north-north configuration. So next slide here, there's the assembly glued together, epoxied together. And there's a rock. Well, there's lots of rocks in Arizona, okay? You just pick one up. And there's my ordinary rock is a test rock, okay? Because you want to conduct a test using something that's neutral, okay? And then your opposing magnets. And I'll show that here. Okay, so that's what I did. You know, I took some electrical tape, just wrap them all up so you could see it easily on the videotape, okay? And I did something extra. You know, I went for extra credit on this test. And the extra credit part dealt with magnets in the attractive configuration. Now, Boyd did not address this at all, okay? Magnets in the attractive configuration makes an excellent test subject as well, okay? So there on the right, the red, you have south, north, north, south. That's your rock there. And so I replicated Boyd Bushman's test, okay? And lo and behold, the man is absolutely correct, okay? And what you see is a change in the mass acceleration effect. And the rock fell slower, okay? There's an anti-gravitational effect associated with magnetism, okay? We're going back to the scalar function here, not the electromagnetic, but the longitudinal scalar function here, okay? That the mass acceleration effect decreases with these rocks in the opposing configuration, okay? They fall slower. But then, for extra credit here, I did the Boyd Bushman experiment with magnets in the attractive configuration, okay? That was very interesting as well, because it fell faster, okay? So the video, show here on the video, it's about maybe 1.5 feet, maybe 2 foot difference through with the test rock and your opposing configuration, and then I ran the test in the attractive configuration as well. Okay. And in the attractive configuration, the rock, that test rock or the magnets fell faster. And it turns out an experimenter by the name of Bruce De Palma, okay, the brother of Brian, the famous director Brian De Palma, Bruce, MIT graduate, did this test, did a test as well, okay, with spinning ball bearings, okay, about maybe a ½ inch to an inch in diameter. He would spin stainless steel balls up to 20,000 RPM, I think, and observed the same effect, okay, that it would fall faster. Okay, so this is what we're seeing here with the magnets. So Boyd is absolutely correct. I recommend that you see the Boyd-Bushman experiment here. So the next slide. So what does this mean? Okay, so that we have magnets doing something very interesting. They not only produce a magnetic field, but they also bend space-time. Okay, physicist, I don't think knows this. Your average physicist does not know this. Okay, that magnets bend space-time as well. Okay, so what we see with the gravitic is that time slows down, but in anti-gravitic, time speeds up. Okay, and so we see this curvature in space-time. So what does that mean? Well, guess what? We can build an Alcubierre warp drive with this concept. Okay, just using magnets in opposing and attractive configuration, because they bend space-time as well. Next slide. I call it the Alek Bushman Alcubierre warp drive engine propulsion technology. Okay, and you'll see something there. Oh my God, that looks like Star Trek, doesn't it? With the double nacelles, and they spin in opposite directions. And you'll see that in the original version of Star Trek. Okay, is that their effects, they spin in opposite directions. Why do they do that? Well, magnets counter-rotate to eliminate the P factor. Okay, because you're really spinning these magnets to enhanced effect. And I believe that's called the Barnard effect. Okay, so that's what we're doing to create warp drive. Okay, using the Alcubierre warp drive method here of bending space-time using magnets. Okay, and you spin them. Next slide. Okay, Star Wars, right? Well, in Star Wars, they just, if you look at their vehicles, they're quite fascinating, okay? Because you see levitation, anti-gravity, combined with jet engine technology, okay? You see that in a lot of their vehicles. And I just find that intriguing with Ray's speeder in this case. You'll see this incredible machine, although it's a movie prop, obviously. But the idea here, the concept is still there, okay? Because you still see the anti-gravitational effect combined with jet engine technology to move you along. Fascinating, very fascinating. And a lot of vehicles in Star Wars use this technique. So I just found that intriguing, okay? Next slide. I'm not anti-gravity, folks, okay? But our technology is. Something cute I came up with here. There's my business card. That's how you can reach me. And so here are the lecture references. So that is my lecture for tonight. So these are all the links you can check out I highly recommend Tom Bearden's psychotronics lecture here on free energy and anti-gravity. Okay, scalar physics, that's a great video here. I did an interview with Steve Ellswick. And here's the Boyd-Bushman magnet drop experiment. Okay, I also recommend you check that out as well. Okay. And this is my presentation here, references, website, email. Okay. And that's the show.
Bill, thank you, sir. That is awesome. Let me do this. I'm going to stop the share. Okay. And you know what? We gotta clap for Bill, everybody. So big applause for Mr. William Alek talking about Bearden's technology as well as possible anti-gravity connections, energy connections. There's all sorts of stuff there. Bill, thank you, sir. Thank you.
Yes.
And again, these are right now. So open mic these are going up on the Alt Propulsion channel, on the YouTube channel, and I'm going to build pages for them as well. I'm just a little bit slow on that on the website. So, okay. So actually we had other folks. Let me go to Mr. Andrew Auregema next. Andrew.
Thanks, Tim.
Yep, absolutely, sir. And let me spotlight
my
you.
presentation is in no way that detailed, and I want to state clearly for the record, no one agrees with anything you're about to see, nor would they ever fess up to believing anything you're about to see. But with that said, I just want to throw out a couple of slides, and this is my understanding of how the I'm just going to call it the universe makes thrust out of nothing. So with that, I'm going to go ahead and get started. And I hate technology, and technology hates me.
So Andrew, if you want to share, my friend, it is a green button down at the bottom, share screen.
Oh, share screen. Okay.
Yeah. And then it's going to make you select which one you want to share. And let me apologize for not doing Q&A after Bill's one. I'm cruising on through because I got folks asking, but we'll come back to Bill if that's cool. We'll come back to Bearden in a bit. Perfect. Looks wonderful, sir.
Okay. How do I tell what I'm showing? Can you see a screen that has?
Yeah, it's showing the Casimir force graphic PowerPoint.
Okay, so I don't see anything. All right, that's cool. I just don't see it on my Zoom screen. Okay, well, then I'll just go ahead and work off of my screen over here. This is in general a piece of lucite, a piece of plastic, a piece of paper. It doesn't matter what. It's just a piece of matter. It's basically a rectangle. It's got some width to it. It's got some thickness to it. It's got a side A and a side B. And I went out online to see if I could put together some words and some pictures that kind of depict how the world thinks, or at least the general opinion of what quantum dynamics looks like when interacting with matter. So from what I can gather, there's a thing called the free vacuum mode density, and there's a basic concept called the Casimir force. And the free mode vacuum density can pass through matter. It's inside matter, it's outside matter, it's all around matter. This is just a general description that I want to show off of how I see the universe. There's matter in this free mode, this free vacuum mode density. Did it change? Okay, did the slide change? Because I can't tell.
Yeah,
Okay,
so you're on slide number 2 now, sir.
Good. Okay, because again, I can't see anything on the screen. Doesn't matter. This is just some more stuff, as I understand it, that goes on in space. You have these little wink in, wink out things that are called virtual photons. They're depicted as kind of little, looks like a lava lamp sometimes. Things just kind of bloop into existence, and they bloop out of existence, and this happens, I don't know, countless number of times per second at the Planck scale. It's the quantum froth or something. It doesn't matter. There's an infinite number of these things. There's a countless number of virtual photons. They are to the left, right, above, below, and within the plate. They're winking in and out of existence every instant. These virtual particles have a whole host of associated properties, including things like momentum, velocity, mass, kinetic, and potential energy. I'm sure there's 1,000 more things they do have that I don't understand and wouldn't understand. But the short and long of it is, the Casimir force, as I understand it, is the accumulation of these countless virtual photons interacting with condensed, real, neutral matter, bound and free charges, which pretty much makes up everything that we call matter and everything that isn't vacuum. So there's the vacuum wink in, wink outness that I don't understand, and then there's real matter that I do understand. So when these wink ins and wink outs interact with real matter, they generate a kind of generic Casimir force, which if this cardboard block is the only thing in the whole universe, then all the forces are equal and the block doesn't move. Nor would it continue to move, because there's no reason for it to, because all the forces on every single particle, and we're talking all the way down to quarks, I think, all of the interactions are completely balanced, and there's just no reason for this thing to go anywhere. So bring it on to what I discovered. Not all virtual photon matter interactions are created equal. And I'm sure there's, I think there's like 47 things on the standard whatever. There's all kinds of subparticles and things and quarks and ups and downs. I don't know what any of it is. These are the four big ones. There's neutrons, protons, there's free charge, and there's bound charge. And I just represented them very simplistically. You still have the free vacuum mode density in the plate. There's an endless number of protons, neutrons. Most plates, if they're like metallic, will have free charge. Most materials, if they're non-conductive, will have bound charge, either on the plate, in the plate, some way. So these are the big hitters. And why does anybody care about why I think all this stuff exists? Because our version of propulsion, we figured out, my team figured out, that if you have virtual photons and you have an engineered collection of them and you arrange the way that they interact with bound charge, then the net force is observable as momentum transfer from the quantum realm into the macro realm. So when you set up the initial conditions, as we do in one of our warp experiments, one of our impulse engine experiments, we're not actually warping anything, we're just stealing momentum from the universe. We can establish more bound charge in a certain direction such that there is a net imbalance of virtual photons slamming into bound charge. The virtual photons come into existence with, and we'll just say X amount of momentum. They leave existence with less. That momentum is transferred to the bound charge. The bound charge can't go anywhere. It's actually trapped. That's why it's called bound. And bound charge that absorbs momentum, that's like saying you've just absorbed momentum into the block that the charge is bound in. So if you have a block of lucite with billions of trapped electrons in it, and you somehow figure out a clever way to slam them bad boys with more virtual photons on one side than the other, then you can generate a net observable momentum transfer, which is what we do. And as of this morning, I'm at 63.5% Earth unity, which means that I can cause a bit of material to lift 65 or 63.5% of its own weight in high vacuum based on this principle. That's it. Again, no one agrees with me. No sane person would agree with me, but that's what I think.
Andrew, that is awesome. That is awesome. Fortunately, there are few sane people with us today. So
any
just
questions, or are we just
visionaries.
moving on to the next presenter?
You know what? Let me do this. So you know what? Let me stop the screen share real quick.
Sure.
Well, that actually makes sense, Andrew.
Okay. And I'm going to put this on
Down
gallery.
charge.
Everybody, applause
You
for
two need
Andrew.
you two need psychological help, because I know
we're
do.
making up for lost time on the applause chain here. So
Hey, Drew, did you say that you got 65% now?
62.5.
62? That number just keeps climbing, man.
Yes, yes, it
So
does.
yeah, I mean, guys, this is mellow. It's open discussion. So Todd's raising his hand. The only thing I would mention is the only person who's requested to go today still that I remember is Phil, and Phil had a demo that he wanted to do. I'm not even sure if he's here, but we got lots and lots of time. Phil is here, Mr. Philippe Bouchard.
Andrew, I just wanted to say that when you accelerate that plate, you'll have more photons hitting one side than the other.
Okay. I don't know where they're coming from, so sure.
Well, it's the same principle. If you had more photons from the virtual particles in the vacuum, it would push it and accelerate it in, from that side. But if you accelerate the plate itself, you have the opposite effect. And
that might be the whole
vacuum photons become real.
Yeah, that might be the whole light speed penalty thing. That may be where it is. I really don't know. But these virtual particles, these are like, I think 31, they're like 10 to the 31 times smaller than the things they're interacting with. Okay, so if they're interacting with like an electron, which is a pretty small thing as far as I can understand, these virtual particles are down around like 10 to the minus 60 on the Planck scale or something.
It doesn't, it's not that, it's not the size that matters, it's their field, the field strength.
Sure, but I'm just saying there's a lot of them. They're really little, and they
which field though?
Each
Magnetic?
pack a tiny bit of sting, and we're stealing a fraction of a fraction of a fraction of a penny from everybody on Earth every second. That's just an analogy. We're not actually stealing any money from anybody, and that would be really sad to do so. But we are stealing momentum from, call it what you will, subspace, the Planck scale, God, doesn't matter what you call it. We're stealing it, and we're using it to what we want to do with it. And I don't know. I don't think anyone's ever going to send me a bill, so I'm not going to worry about it too much.
Well, it's an equilibrium. The matter in that plate is an equilibrium. It's absorbing energy from the vacuum, but it's also radiating it back.
Okay.
And you have to break that equilibrium to make it go.
Yeah. Well, I figure that at about, I figured about 30% Earth gravity G. So I can make about a third of a G, I think. I can like put together a system, actually plates and plate holders and, all the stuff that it's going to take to make an engine. At about a third of a G, I figure I can hit 0.9 light speed on the way to Alpha Centauri.
That would be impressive. So far,
it's just real space. I mean, you're just pushing a rock. You just never shut the engine off, and you push the rock for 3.5, 4 years. It's about 8 years to Alpha Centauri at a third of a G. I'm not going. I'm just saying, if I were to put a virtual astronaut on my little virtual spaceship, he'd have about an 8-year trip ahead of him.
So do you have any idea of any particular material that you could think of to devise that would permit you to get that imbalance from the virtual vacuum? Are you saying that you're exploring that too? I thought you had another concept about.
Yes, we are. This is the caveman version of our propulsion system. This is what we have, and this is where we got to, but where we're going is anywhere from 10 to 1,000x this concept.
So again, are you saying, I'm sorry, are you saying that you are exploring a material that will permit that imbalance of charge, or are you not?
We are.
Oh, okay. I didn't understand. Thanks.
Okay, sorry about that. So guys, who else has questions? Anybody else questions for Andrew? And if not, we can
I
go
have
to
one.
Phil. Oh, yeah, go for it, Mike.
Andrew, when you're hitting that site with a charge, is that a one-time pulse?
Well, we have done it with a charge up system, but it just shorts out. No, it's a continuous, it's a continuous feed.
Low amperage feed or pulse?
It's a continuous feed. I'm not going to get into
Constant
the
current?
specifics of it. We've figured out a very clever way to create an asymmetry in the charge in the plate, such that there's more virtual photons smacking one side than the other. As long as you keep up that initial conditions, you get to have thrust. You let the initial conditions collapse back to random, and the thrust goes to zero.
So you experimentally demonstrated that with this voltage disparity and this quantum vacuum fluctuation, that in fact you have achieved thrust?
Yeah, we're making 62.5% of the mass of the object is worth of thrust.
Oh, that's something that NASA would probably like to buy from you. And
No, they wouldn't. You'd be amazed. One of our team is NASA, and they don't care
why not?
because they're NASA and they're stupid. I don't know why.
Okay, I just
I've
thought,
worked for them for 30 years. Nothing makes sense inside that realm of madness.
okay,
NASA, they do, yeah. They have their own.
They march to their own drummer, and it has nothing to do with space exploration or moving the needle forward. Nothing at all. For those of you who think NASA is the solution to anything, you're wrong.
So what kind of power are you giving this thing, Andrew?
Well, right now we're in microwatts. So yeah, we're in microwatts per millinewtons.
Jeez.
But it'll be microwatts per newton, because all it is the capacitor. You know, once you charge a capacitor up, it doesn't take anything to keep it charged. It just doesn't go in. The charge doesn't go anywhere. It's not doing any work.
You're just keeping the potential steady or whatever.
Yeah, it's a capacitor.
well, now you mentioned that NASA couldn't care less about this. So the other alternative, I would assume, would be people like Elon Musk, who or some other billionaire who wants to make money. Why do you feel like people of that realm would be possibly interested, or are they as intransigent in your view as NASA? I'm kind of puzzled as to why people who are rich would not want to exploit what you have to offer, because they're always interested in making cash. So I don't know.
I have no insight into humans and how they make decisions. None at all. I'm just an engineer, and you know, life has taught me that engineers think differently than other people, so don't bother trying to figure them out. I don't know who would be interested and who wouldn't be interested, but we've been looking for, sponsorship for a very long time. But as you know,
for the
because
freight
you're a part of
industry.
this world, the well has been poisoned by insane people ahead of us, people who are literally insane, and they've been spouting madness for decades. And when that's the predecessor, and you come along and you've got a unicorn that can dance and sing and recite Shakespeare, nobody believes you. So it's
Well, I can kind of understand that from one viewpoint. It's like if somebody came along with an anti-fat medicine that actually worked, and all of a sudden people who were diabetic ceased to be diabetic. Do you imagine that people who manufacture insulin and needles would be particularly thrilled that you came along with something that'll disrupt their technology? There's billions of dollars in rocket boosters, spacecraft, and here you come along with your ideas. You think people are going to be receptive to what you have to offer because of that? I don't think so. They'll say,
exactly.
no clue.
we don't want to this guy, he's taking away our money. So yeah,
innovative solution is not their goal is to get us in debt, big banks and all that, and make profit of the interest. So innovative solution, they're against that stuff. So that's my explanation.
Well,
but
if I could jump in, this has been studied pretty well, and you could use Tesla as kind of a case study and stuff like this. But so typically when you have a disruptive technology that comes out and disrupts the market, right, as it were, and what Andrew is working on would definitely qualify as that. Typically what happens is entrenched interests just say that it won't work. They kind of keep their head in the sand, and they have so many ongoing, business obligations that they just basically ignore it or poo-poo it. And it kind of sails right on past them. And if you look, I might be mistaken, but for at least several months now, Tesla has been like the #1 auto manufacturer in the US or something like that. And that happened right under the noses of Ford and General Motors, right? Who, just couldn't be bothered to get into electric. Well, Tesla is like pushing 20 years old now. So none of this is like a news break, but what it is just that they were so tied up with what they were already doing. And they were like, you know what, we'll get to this when we get to this, and we'll come to it later. And later just never happened. And so now in like 2020 was when they started really getting serious about electric vehicles. They are so far behind the curve that they'll probably never catch up. But that's very traditional. It happens in computing. It happens in pretty much any major industry. And it's been studied and documented as it's kind of a human phenomenon with innovation. So it's just the way the world works, unfortunately. And NASA is, I would assume, no exception to that.
I got one other question for William Alek. I guess that's how you pronounce your name. Have you gotten any videos of, I didn't follow exactly what you were talking about, but do you have any videos of your scalar field cancellation, whatever it was, demonstrating the possibilities on your side, or where are you at on an experimental basis?
Well, what I have is a test bench. Okay. And the test bench shows you the waveform that you're after, the scalar waveform. And I haven't done anything with a balance beam, looking at anything with anti-gravitational. My main interest is showing the resonance, okay, of this, hooked up to a capacitor and a resistive load, and showing the increase in efficiency, okay? None of my coils are balanced. Stanley Myers had a method of balancing coils, okay, where your efficiency goes way up. You're no longer at this 100% barrier, okay, that we typically have in a lot of our power electronics, okay? So your efficiencies can go way up when you're working with balanced coils, okay? Now, personally, I haven't done that. My main purpose is to show the scalar waveform, okay, that you see on your oscilloscope, and showing how as you change the frequency, the efficiency will start to go up, okay, as you approach resonance. That's my thrust of doing this technology. Okay. Now my next step is, I want to hook this up to my car. Okay, the scalar technology up to my car, like what Stanley Myers was doing, and burn water, not gasoline, and get away from this hydrocarbon pollution method that we have here, and burn water. Okay, that's kind of like my next step in all of this, is producing that hydroxy gas. Okay, very efficiently. You want to do this very efficiently, because a typical method it takes a lot of power to make hydroxy gas. Okay, but you can do it very efficiently with using the scalar wave technology. Okay, where efficiency goes way up. Okay, and so that's kind of the direction that I want to go in. Okay,
Where's the extra energy coming from? I mean, if it takes X amount of joules to crack an ounce of water,
right,
and you somehow magically get 300% efficiency out of your water cracking system, where's the extra energy coming from?
The magnetic field.
Yeah, I mean, we're canceling out the magnetic component. Okay, you heard of Townsend Brown, right? And his technology. I mean, this stuff is all related. Okay, when you look at the lifter technology that Tim Ventura was working in. Okay,
yeah, I messed around with lifters for 10 years. They were worthless. Where's the energy coming from?
Well, the objective is to run this system in resonance. Okay, so
Sure.
Your input current goes way down. Okay, you have this reverse profile. Okay, on your input current.
So you're somehow weakening the bonds between the atoms?
The reverse profile. I have a comment for that.
No, we're getting rid of the magnetic. See, your magnetic component is tied to inertia. Okay, we're getting rid of that. We want to get rid of that as much as possible. Okay, your magnetic component. And so we see that, with this kind of tech, like Floyd Sweet, Stanley Myers, their objective is to get rid of this magnetic component, because that's what slows you down. Okay, that's your inertial component. And when you start to get rid of that, your input current will start, you see this dip on your input side. And you see that as you approach resonance, the scalar term starts to emerge. Your sine squared term starts to become dominant. Okay, and so that's your objective, is to achieve this kind of effect with your sine squared term.
So basically, you have an over unity system,
right?
Where you're stealing the energy from.
When you do that, your efficiency goes way up.
I don't care what the efficiency is. Okay. If you're over unity, where are you stealing the energy from? Well, in theory, you could crack gas, you could crack water, burn the water, generate electricity, and have more power than when you started. That's the definition
using
of
electromagnetics.
Where's the energy coming
from? That's right.
Where are you stealing the energy from?
The gravitomagnetic field.
It doesn't matter what you call it. Where are you getting it from?
You use electromagnetic field.
It doesn't matter what you call it. Where are you getting the energy from? Guys, the
ether.
Conservation of momentum still works, no matter where you are.
Reverse voltage.
I think
it's time reversed as well. Okay.
It's the flyback that
time
occurs
reversal
after the on cycle of a pulse.
I think he's saying he steals
from the scalar waves.
It's a repeatable experiment, so therefore it's science.
Is he saying he's
in the capacitor?
I mean,
it's
there's
an
no
open
arguing
system.
the flyback.
It's an open system.
I haven't heard anything yet that says where you're stealing the energy from. Maybe I'm just missing it.
They're-
As
it's
those
from
words
the
actually come out of
quantum
anybody's mouth?
vacuum.
I wouldn't
See,
call
the
it stealing.
device
Quantum
runs
vacuum.
cold. It doesn't
given.
run hot. These devices, they run cold.
Huh.
They don't
That's
run
nice.
hot.
So
So what,
forward
you're
voltage is
stealing-
hot, is explosive energy, and reverse voltage is implosive energy, and it's cold.
Yeah.
And it happens during
It's
the
the
off
opposite
cycle of a
direction.
DC pulse.
Well,
Yeah,
So it's a repeatable experiment.
So is he saying he's stealing the energy from the?
And when you open the circuit open the switch to a circuit, there's nowhere for your power to flow, yet something is flowing. It's called a reverse flyback. How is anything going to flow when the circuit's open? Yet the inductor is flying back in the reverse polarity when that happens, when the off cycle happens.
Okay, you're
Circuit's
mixing
open.
a whole bunch of nonsense
There's
together.
nowhere for your forward voltage to flow. Circuit is open. But yet there is a reverse flyback occurring in the devices, including the inductor, mostly the inductor. And that's
Yeah,
called flyback voltage.
You're
They use
talking
that
about an
flyback
inductive
driver
field.
to run these asymmetric
That's nice.
levitators.
None of the words you just said has anything to do with my question. Where are you stealing
The
the energy
flyback
from?
voltage is not forward voltage. It's not your energy. Because the circuit's open when it happens. I'll say it again.
It doesn't matter how many times you say it. You haven't said anything that answers the question.
restate the question.
I
Where is
I
the-
can ask.
This
Wait,
is an over unity system. Theoretically, you can make fuel, burn the fuel, run a generator, and make more power than you started with. That's the definition of over unity.
Oh,
Forgot where William is claiming this is an over unity system, which is fine. I love stealing energy from the universe. But where are you stealing the energy that's you're accumulating? Because you're literally accumulating energy here.
well, what I heard from William was that it was coming from the vacuum itself.
Yeah,
That it's coming
it's
from the
explosive
vacuum.
energy. It's way
And
stronger than
vacuum
energy.
by I guess what he means
You
by
thought
vacuum.
of another clever way to steal momentum or thermal energy or whatever from the quantum vacuum?
by running it in reverse.
So you
It
have
runs in
explosive
reverse.
energy and you have implosive energy. The Victor
Right.
Schauberger is based on implosive energy.
I mean,
So
when you
the
think
way
about
the
it,
way I explain it is you're
The
changing
implosive
the
energy
medium.
is 100 times
The
stronger than the
space-time
explosive
medium
energy.
changes when you go from a matter a region where there's matter, and then you go to a region where the matter is missing. The space-time medium itself is changing.
That creates a
Okay.
vacuum. where matter
I
is
think-
missing.
And so as you go towards a denser space-time medium, time slows down. As you go away from a denser to a expanded space-time medium, time goes faster. And that's consistent with general relativity. So what's going on is we're talking about GR, but we're just talking about it using quantum theory. So it's the same stuff though. It's the what we call the vacuum. Vacuum isn't constant.
Yeah, but the vacuum energy from the theory is not as strong as what was measured. It's called the vacuum catastrophe.
Well, I don't think it's like Casimir. I think it's that Andrew was talking about. I think was it you, Andrew, were talking about when you go faster, these virtual electrons, the profile changes.
Oh, I have no idea. That was somebody else.
Okay. Sorry.
All right, so I'm just gonna assume that you don't know where you're getting the energy from, but that's fine.
The,
I don't really know
the
what
I told
idea,
you,
From
it's
the
going from
implosive,
change of
the
from the
idea-
From the
implosive
vacuum.
directional field,
I
which
mean,
is the reverse direction of your
it
direction.
would.
I
I
can-
think. I think with any over unity system, ultimately the excess energy would have to come from the vacuum, right? At some point.
agree.
So,
Correct.
yeah.
Well,
So,
I haven't
it would
experienced over
have to-
unity. I've experienced no loss.
Well, so yeah, I mean, what my thought would be, and like devices running cold, again, it could be taking, in theory, right? Brownian motion, maybe it's converting Brownian motion, maybe it's extracting energy from that, maybe it's absorbing energy from the surrounding environment. I mean, but ultimately, when you trace that back, right, when you go up the pipe, it's got to go back to the vacuum at some point. So,
yeah, but I think he means Andrew was saying is conservation laws respected is what he was really talking about. And
well, not with over unity. No, conservation would not be respected with over unity. That would be the definition of over unity.
well, then you're breaking the laws of the universe at that point. And how do you account for breaking the laws of the universe?
Well, all of our laws do not include implosive energy.
Well,
which
it's a
is
law
the
of
reverse
thermodynamics. That's not necessarily a law of the universe, right? I mean, unless God came down and wrote it in the thermodynamics Bible. My thought would be it's generally accepted as a governing principle of the way that things work. Yeah, but I mean, various people seem to be demonstrating at least short-term workarounds. So who knows? I mean,
I have this table from Hal Puthoff's paper that explains what I was trying to express in my previous statement. Would it be okay for me to share that?
Yeah, put it on up. Yeah. We're being mellow. And guys, I hope I'm doing okay moderating. I'm trying to just kind of be mellow today. And
okay, so
let me know if I'm missing the ball though.
Can you see this?
Yes.
Okay, so here's Hal's. Basically, this is a table from his paper that he wrote, and it's the table is metric effects on physical processes in an altered space-time is interpreted by a remote, unaltered space-time observer. So when I was talking about what I call denser space-time, basically when you get closer to a denser mass, it affects the space-time around it. For example, time intervals, process clocks run slower. Frequency is redshifted to lower frequencies. Energy states are lowered. Objects, e.g. rulers, shrink. The effective velocity of light is less than c. The effective mass increases. And the force is a gravitational or a pull force. In what they call space-time metric, engineered metric, or what I call expanded space-time, processes, e.g. clocks, run faster. Frequency blue shifts towards higher frequency. Energy states are raised. Objects, e.g. rulers, expand. Effective velocity is greater than the speed of light. Effective mass decreases. And the force is anti-gravitational or repulsive. Now that's exactly what William was describing, and you were asking him where the energy comes from, and what I'm saying is one of the current theories is that it's this process of metric effects on physical processes in altered space-time. So we're changing from one medium to another medium. That's what's created. So that's where the energy difference is coming from. Does that help, Andrew?
How do you make a space-time engineered metric? I know how to make a star.
Okay,
How
well,
do you do
that's a fair question. So here's how I did it. I made these little nanobumps and nanopits, and I put them on a spinning disk. And then I measured with this sensor on the spinning disk that is called a GMR sensor, which stands for Giant Magnetoresistor. It's not because it's giant, but because it's very sensitive to the changing magnetic fields. So so that's a part of your hard disk drive. and it's what reads the little magnetic bits on the surfaces, the magnetic film on your hard disk. Now, the other thing I did is I put this a piezoelectric sensor on the back of what's called the slider, this part that looks kind of like a sled. And so, what that does is it detects physical, it detects physical force, like a push or a pull. And so when in this case, I'm showing a nano bump goes under this little arm with the sled on it, it pulled it down, and you can see the signal there on the left in the piezoelectric sensor. That's it's like pulled it down and it went boing like a spring, I mean. It's like an undampened spring force. So it like wiggled it for a lot longer than it should. And then you look on the right, and that's the giant magnetometer resistor. Okay, and now I did the same thing with a pit. And with the pit, when it ran under it, it created a little physical push force against the force of gravity. And the GMR signal was of the opposite polarity. Now, with the signals, I can distinguish the electromagnetic induction from the gravitomagnetic induction, because where the edge of the little bump is, the magnetic field switches at the edge because the change in the angle moves 90 degrees, and by the right hand rule, it's going to create an induction signal. So when the bump edge goes over the bump, it creates a magnetic induction signal at the speed of light. And then when it comes back down on the other side of the bump, you can see the opposite polarity of magnetic induction is produced. If you go to but where the gravitomagnetic signal is this broader signal in the middle between the two electromagnetic pulses. And there's a time difference between that first electromagnetic induction pulse and the gravitomagnetic induction pulse going down of 1 microsecond, because that time delay is due to frame dragging, because the speed of gravity isn't as fast as the speed of light. Or else because see, light photons are independent of time because they have no mass. They're massless and timeless. But gravitomagnetism or gravity is time dependent. And that's why it's called space-time, because it's time dependent. And the time depends on the medium, which medium you're in. Are you in the expanded or the denser space-time, or are you in our non-affected space-time that we reference everything to? So essentially, it's a physical property that we can measure. And my hypothesis is, if you look at this video here I have of the Tic Tac UAP, you can see this expanded space-time effect above it. This little bubble, this black bubble over the top, that's an anti-gravity field. So it's not like you think. It's actually creating a bubble of expanded space-time above the Tic Tac that's canceling out the gravitational force. On the right here, you can see these other little bubbles, and they're brighter. That's the denser space-time. And then on the left, this dark region where the object or the Tic Tac is traveling into it, or the warp, as they call it, that's expanded space-time. And if you look at it like a bow and an arrow, where the Tic Tac is the arrow, the denser space-time is the bow, and the tension on the bow creates the force that the energy source that propels the Tic Tac into the warp drive on the left. So it's like this Alcubierre drive is what's being used here for the propulsion part of the Tic Tac. But the anti-gravity field is being created by this expanded space-time, this dark region right over the top of the Tic Tac. So this is what I believe, my hypothesis, this isn't magic, this is physics. So that's, I'll stop sharing. But William, I would appreciate it if you put your email address in the chat. If you could do that.
Michael, how come the bubbles didn't follow that Tic Tac?
Well, after it goes into, at some point, the bubble disappears because it doesn't need it for a lift anymore. It's got enough energy.
It's like it just created a virtual magnetic. It created a virtual magnet up there, bubble, to push it in that direction.
Yeah.
Two magnets.
What pushed it was the denser space-time on the right. That's where the energy's coming from. There, it got the energy to go into warp from the more massive space-time. You follow? And then it goes into a less massive space-time. And the way we can see that is because it's using infrared. And that's what my background's in, is infrared. I used to make the infrared detectors. So basically, if you look at it as heat, the dark regions are cooler and the brighter regions are warmer.
Would you say those bubbles were electromagnetic bubbles or gravitomagnetic bubbles, or?
Well, it's an anti-gravity bubble because see, gravity is a second order. It's an acceleration, basically. It's a force based on acceleration, and that's distance squared over time squared. But anti-gravity is distance cubed over time cubed. So it's kind of like it's only strong at the membrane. It's weak inside, kind of like a balloon. If you have a balloon, it's only the membrane part that's, and that's that's like I said, it's third order as opposed to second order. So that's what, and you want, I can show you. Let's see if I can do this. Go back here. Show you more. I had it right here. So when I made my little variable area nano bumps and nano pits like this on the surface of the disk on a radius, and then I plot them. You can see there's it's like a diode, like an electromagnetic diode in a semiconductor junction, only for a gravitational junction. And so what you have is the bumps are producing this pull force, and you can see up here it's a second order force, okay? And then the pits are, if you look here, it's a third order. See? So, and then, you know, this is stuff for my patents that I have, and the reason I was hoping to talk to you more about it, William, is because I have a paper that I just submitted to IEEE Sensors that I was looking at some of your equations and stuff, and I was thinking that might be useful. I don't know if you ever published any of your work, William?
Okay. No.
No?
No. No. My focus was just on what Tom Bearden left out. Kind of filled in the blanks there with Tom's work.
You know,
Well,
I'd almost wondered if I feel stupid even saying this, but like I was looking up neutrinos a lot over the last few months, off and on, right? And you know, I've almost wondered if like what role did those play, right? I mean, when you get especially near the sun, but I mean, the entire galaxy must be just literally full of neutrinos, and you know, these are the binding energy that holds atoms together, and they get ejected from the sun, and they're floating around, and supposedly never interact with anything. I was like, what happens to those? I
Those
mean,
are the things Neo looks at, in the Matrix.
yeah, other than that, I mean, I don't know.
Maybe that is maybe those neutrinos are the lattice of
Maybe,
the.
well, and maybe, you know, but then when you guys are talking about like vacuum energy, right? I'm like, okay, well, you would need a source. I mean, if you have vacuum energy that doesn't violate conservation, maybe somehow it's tapping the
We only see
neutrinos.
them going in one direction, though, from what
I,
and that's
I
the
don't know.
only direction we see them going in. That doesn't mean they're not going in multiple directions. We just only
Well,
see them going in one direction.
yeah, if you look up if you look up the neutrino detector experiments, right, they will talk ad nauseum about, you know, they're everywhere, right? Neutrino density passing through us. They just don't interact much. But you know, but then maybe these over unity devices, maybe again, I'm just spitballing, but like, what if, right? What if they could tap into even a tiny fraction of that energy that's passing through? That would be a source of non-conservation violating energy. I mean, it's energy, it's there, you know, it's not like you're stealing it from someplace. It's what you're doing is just harnessing it, right? Just like solar power. So
but the neutrinos go right through stuff, so you'd have to change the frequency of the neutrino somehow, or
yeah,
change the frequency of the material that or the medium it's going through in such a way that there would be uh, a resonance or anti-resonance in this case.
something like
Michael,
that. I mean,
you suppose neutrinos are just clustered and gathered up like a fishing net by a magnet?
No, they're
And
not
then
magnetic. They're
they're
not magnetic.
batched in
The
together
problem
and
is
then thrown into
neutrinos
copper.
are constantly changing. They're changing phase as they
yeah,
move.
you're right. They change. Yeah, you're right. They change. There's three types, and
There's three types, and they
they
change
change as
phase.
they fly. I don't
How-
know.
And the phase change depends on how fast they're moving. So again, it comes back to this time dependence. That's all about time dependence. Time is the fourth dimension, and it affects everything.
Yeah, you know, and it's just why. I mean, it's beyond wild speculation. It's just something I've wondered about. You know, it's beyond wild speculation. Would be like, okay, I can see how this would work. In this case, I can't even see how it would work. I'm just thinking there's a source of energy, right? Non-conservation violating energy. It's just like, how would you harness it? I don't know. It's just something but some of this stuff too, I'll tell you, the more physics I read, the more I start to question it, right? Like, that's just me.
You have to attach your wheel work to the nature. That's the easy way.
It's so driven by mathematics, and I'm not sure if that's necessarily a good thing. I mean, when you look at Einstein, he had these wonderful conceptual models that he made the mathematics support. But it seems like for most of the 20th century, it's just been mathematics. And then they're like, yeah, well, there's kind of a concept behind it. We just don't know, you know. It's like they'll measure. Well, I'm so for instance, quantum mechanics, the idea behind quantum mechanics is everything has to have both a wave and a particle, right? There's wave particle duality. And the one that always got me was phonons, right? Which is what do they call that now? A quasi particle, a particle of sound. And we know that there's no such thing as a particle of sound. Sound is the movement of other particles, but the thing is, quantum mechanics requires it, right? So obviously the model is just not perfect, you know, but the way that they do the math, it's required. So, you know, I don't know. so that's why with Bearden's and with Bearden's stuff, and again, David Chester would have to talk about this. I don't think he's here, but he texted me. He got really excited. This was 3 or 4 weeks ago, and I don't remember the details of it, but he was digging into other math, and it brought him full circle to Tom Bearden's stuff. And he's like, I wonder if this could explain why it works. But the thing that was interesting was when he was describing it, I was like, and he again, he was talking specifically about Tom Bearden. He's like, okay, the heavy side stuff, he's like that maybe that doesn't work like this, but then he's like, if you approach it from this context, then this is what would make it work. And I was like, and so I don't know. But I think that's why this conference is valuable, right? We're able to kind of start to hash out some of these ideas and match it with experimental stuff.
Well, when it comes to, over unity, that can be demonstrated in simple little experiments, like put some magnets on a wheel, put a piece of iron over there, and notice the wheel will turn to the iron, And if you break that connection, once the magnet gets to the iron, it will stick, right? You could break that connection and it keeps going. You don't want to push it. You just want to break the connection. You don't want to force the magnet along. And if you don't give more energy to push the magnet and you only give enough energy to break the connection, well, what's the wheel going to do? It's going to keep spinning at the speed that the magnet's force to the iron dictates that speed. That's the torque it's going to have. And as long as you keep your energy lower than that torque, that's a perfect example of how over unity can be established.
I think you're almost, it almost sounds like you're describing the Bedini. You are describing the Bedini because you were doing
it's an electric pulse motor.
Yeah.
Yes. But the Bedini circuit is a little more evolved than just your standard pulse motor. It's harnessing a second battery to, instead of throwing out the reverse voltage that occurs after you give your forward pulse to break the connection to that magnet, he takes the reverse pulse and throws it into a second battery. And you don't waste your forward. Well, you do waste your forward energy. That's gone. But when the circuit opens, you're not giving energy anymore, and there's a reverse energy coming into the circuit. And he very strategically aligned a high voltage diode to capture that into a second battery. That's the only difference between a standard pulse motor and the Bedini motor. It's not a standard, read switch kind of thing. It's a little bit extra there. He managed to capture the reverse flyback, reverse voltage that occurs in the coil. So when you charge the coil to energize it and turn it into a magnet, to simply break the connection between the magnet on the wheel and the core, you turn that core into a magnet for that second when it reaches the core, and then you break the connection. By doing that, you're also creating a reverse flow back from your forward pulse that you just created there. And that reverse is being funneled into another battery with the high voltage diode in the Bedini system.
Wait, Rick is saying,
very clever.
Rick is saying, wake Phil up. Phil,
Phil's
are you with
always
us?
sleeping. He's always sleeping, man.
No, Phil is waiting to.
So Phil is dealing with back EMF on his.
Yes, can we go, Phil? Would you like to update us? You have a presentation for us, right?
Sure. I prepared one yesterday for Bernie, but it got postponed. But it's very quick. It's not going to take an hour at all.
Okay. Well, let me do this. Let me spotlight you, and do screen share, I guess.
Okay.
Or do you want a minute? I know it's I know it's later your time. I was kind of teasing. It's like 9 p.m. something your time. So do you want to?
Yeah, I'm sharing my desktop right now.
Okay.
Well,
let me mute myself out then. And
all right, slideshow. All right. By the way, thanks Tim for this group, and thanks for everybody for being persistent to that research, because it's not that easy. But here am I. I just want to go full circle with my theory and show where I'm at, give updates. This is finite theory and gravito-electromagnetism is pretty much final right now. There are things I will disclose too, and things I will not disclose, because I got defense companies evaluating my company right now. So we'll see what happens, but I'll disclose pretty much everything so you understand the high level idea of everything. So finite theory and GEM can explain anti-gravity, force field, superluminal communication, and acceleration, manipulation of acceleration, which is pretty, it's not science fiction anymore. If you manipulate time, then you can manipulate all of those. So next slide. So the assumption that I make is that, and you can see a lot of papers on that right now. It's not a joke anymore. Graviton and photon equivalence. There's a lot of work, a lot of people that assume that it's the same thing. And if I assume it's the same thing, if a graviton is just a photon on a different frequency, then I can explain pretty much everything. So all the numbers work of finite theory, everything works at all levels, at all scales. So it's pretty much amazing. The Hubble, the cosmological microwave background, the size of the universe, the galactic rotation curves, everything. It's the other thing that I failed to mention in my last presentation about a year ago was that I could not explain the because I did reverse engineer the galactic rotation curve of all galaxies, but I had the little fudge factor that was consistent with all galaxies except ours and the Milky Way, and I could not explain it. And that's because I was not considering the angular momentum of the stars, the planets, and the bulge of the galaxies. The angular momentum is actually responsible from inducing time rate, just like an electron is responsible from inducing a magnetic field when it spins or when it moves. I'm going to talk more about spinning because at the macro scale, it's all about spinning planets and stars. So yeah, so that's what I failed to mention last year, but I figured this out recently, actually. It actually helps deducing why gravity and time rate are monopole. That's because the gravito-electric field and the gravito-magnetic field mixed together will create gravitational waves. Gravitational waves are dependent on the angular momentum of the planet, the star, of the black hole. You can see my mainstream equations. By the way, finite theory is 100% mainstream. It's not against the mainstream anymore. So I apologize for creating attention, but it's all mainstream. It's just that I'm using the equation differently. And the gravitational waves are also carrier of time rate. So that's the time dilation. The time dilation, gravitational waves, it's like an ELF wave. That's all it is. And it's a carrier of gravity and time rate. I'm able to reverse engineer all galactic rotation curve. I did that for 500 galactic galaxies. It links the Hubble constant with the size of the universe. That I already explained that last year. Nothing changes there, but I get the exact same order of magnitude to explain the size of the universe. Explain everything like I was saying last year, the perihelion precession, the light bending, the Pound-Rebka experiment, and the real distance of the moon, the distance of the discrepancy of the distance of the moon. There's a 14 meters discrepancy from what we think the moon is. And most importantly, it's not suffering from the vacuum catastrophe. We know that JR does with the dark energy thing. Unfortunately, there's not as much energy in the vacuum as JR suggests. That was proven experimentally using multiple ways. So finite theory does not have that deficiency on the vacuum catastrophe paradox. And it does not imply there's no paradox or, no grandpa paradox implied or all that stuff. So that's what it implies. I wrote a software for that, but I did reverse engineer 500 galaxies rotation curves using my theory, and I get the exact same rotation curve, the exact same curve. The equation is very simple. I'll show you. It's in my paper. I'll show you at the end. I'll show the link at the end, and it's very simple. I can explain all galactic rotation curves. The same with the Milky Way. So there's it's not a big mystery anymore. And like I was explaining again last year, this is the distance. This is the actual size of the universe. This is the distance from the universal core, like I was saying last year. The visible universe, it's like a bubble universe that has a certain velocity that moves within a greater universe, and it has the distance. What we see is actually multiple universes, and the distance we are from that is 1.3 times 10 to the 26 meters, which the exact same order of magnitude as what the mainstream predicts. So there's no change there, but I'm using completely different way. And the fun part here, the gravito-electromagnetic permeability, using the Biot-Savart equations and the fact that the relation with the speed of an electric field that induces a magnetic field, I get exactly the same gravito-magnetic permeability using the Biot-Savart and the mainstream, which is the Newton's gravitational constant divided by the speed of light squared. There's a 6 pi discrepancy there, but that I'll have to investigate. But I get the exact same order of magnitude as the mainstream gravito-magnetic permeability. So, there's no change there. There's nothing new there. The difference with my theory and the mainstream is that I get also a relative gravito-electromagnetic permeability caused by the cosmological microwave background. If I add the cosmological microwave background radiation, which is a microwave, or 10 times 10 to the 11 hertz, then we're gonna get a relative gravito-electromagnetic permeability. So that explains why I get a shift in gravity with my MHD vortex experiment. That explains why Sergio also does get a shift in gravity with his Mercury vortex. So that explains everything. That was the missing piece of the puzzle right there. There was a missing relative gravito-electromagnetic permeability, and I'm also able to predict not only anti-gravity or weight alleviation, but I'm also able to predict the force field using Elf waves, the superluminal communication, and most importantly, the energy teleportation. So you can convert back and forth the energy, so you can supply a vehicle on demand, on the fly, in any situation. So I'm gonna write a patent on that. That's why I don't disclose the equations, but that's its potential. I know it's gonna work, because if I assume that the graviton and the photon again is the same, then all my equations they work. I get the exact same order of magnitude that I expect. So here's more information on my manuscript. It's actually static.fornars.com/files/pdf/finite theory finite_theory.pdf. Here's my YouTube channel as well. It's at Bouchard8, Bouchard with a D at the end and 8. And here's my email address, phil@fornars.com. I'm the founder of CEO of my own company. And stay tuned, because I'm going to show you very, very interesting videos as well. So I'm going to get out of there. Okay. He did also successfully show an experiment with prove that anti-gravity was working with the Mercury vortex. So I'm not at the right. Yeah. So anyway, I can post the link in the chat, but I'm gonna show Sergio's.
What is it about Mercury?
Yeah, it's a Mercury vortex.
I mean, why Mercury though? Why not water or anything else? Why are they spinning Mercury?
I use gallium. That's because Mercury and gallium. Mercury and gallium have a high mass density, so it's more dense, so you get it to rotate very fast. It's going to generate time dilation, and time dilation will
That's interesting.
will alter the gravitational acceleration. You know, a gravitational acceleration is meters.
So you're looking for more mass, more dense material, liquid material.
Exactly.
What about deuterium water? That's dense water. Is that heavier than mercury? Or no?
I'll have to check it out. There's also another material.
There's heavy water, you know.
The Nazis Bell were using. It's another material. I forgot the name, but there are 3 liquid metal that we can use. You don't want it to be magnetic as well, because if you use magnetohydrodynamics, there's going to be interference from a magnetic field.
Mercury is not magnetic?
No, neither is gallium. And I have an experiment right here, right in front of me. It's I'm using neodymium magnets that generate 3 Teslas. I'm using zirconium rings, metal rings, because they don't interfere with magnetic fields. And inside there's gallium. The only problem with gallium, it's safer than mercury. The only problem is you have to heat it up every time you want to use it. So I have a welder to do that. But
What's
yeah,
the advantage of what's the advantage of spinning a non-magnetic material as opposed to a magnetic material?
there's no difference.
There's no advantage to
There's
either
no
or?
difference as long as it's a mass in motion. As long as the mass moves, it's gonna create time dilation. Time dilation will alter the gravitational acceleration. So that's the theory. And I did my own experiment. I'm showing off Sergio's experiment right now. He did see a shift. You see dot 280 on his weight scale right now. It's gonna shift down a little bit to 275.
And you couldn't just spin an iron ring and have the same effect? It's mass.
Yeah, we could, but the idea of using magnetohydrodynamics is that the problem with a disk, I mean a solid disk, is gonna break apart if you spin it very fast. It's hard to keep it contained, solid.
So the RPMs are too high.
Yeah, exactly. You can't go higher with the RPM, but it's gonna break apart. My goal with MHD was to do the same thing at high speed, but I need
What
high
about spinning
power.
gas in a tube?
Yeah, gas has less mass
And
density.
not much mass, right?
Yeah. So yeah. Anyway, sorry, I was talking while the video was showing, but if you replay the video, the weight loss, the balance went down to 275, and so it did lose weight. Same thing on my end, and so yeah, so it does work. It creates gravitational acceleration shift. 2 or 3 years ago, I used the Dyson V11 engine that spins 130 RPM. I was able to measure weight shift with that as well. So right now I'm just I need to buy capacitors to have a greater power, greater amount of electricity to make my galleon spins faster. I don't need it for. I don't need the galleon to spin for a long time, but I just want to show that there is indeed a shift, and very, very, very like unequivocally, like that it really works because I didn't make videos before, but I had comments. Oh, it could be this, or it could be that. So I want to eliminate all the doubts. And so right now I'm at that stage. I'm talking to defense companies as well, so they're evaluating what I'm saying right now. So we'll see what happens. And but yeah, I mean, keep in mind that the mass induces time dilation, and that pretty much explains everything. The mass in motion induces time dilation. Sorry. So yeah, that's pretty much all I had to say today. But thanks for your time, and if you have any question, just let me know.
Phil,
that's awesome. That is.
I had a quick one.
Well, you know what?
What if you?
Sorry, let me do this first. Everybody, we need to give Phil a giant applause. Mr. Bouchard, thank you, sir.
Mm-hmm.
I am trying to get better because the applause is traditional. We got to do that, right? And we have to. That's obligatory at this point. And Phil, thank you, sir. Phil's done a bunch of work, but sorry, Mike, I didn't mean to cut you off, sir.
Phil, what if you had like a lot more mercury per se, a lot more mass? Would you still have to reach the high RPMs, or could you go on a lower RPM to achieve the same results because you have more mass?
if you have more mass, it's
Are the
gonna,
RPMs necessary at such high RPMs when you have more mass?
yeah, you need, obviously it's harder to reach great speed with massive stuff than plasma and stuff like that. But you could use plasma and make it spin like near the speed of light or whatever. It's gonna work, but it's less massive. So it's kind of balance. They all balance. You know what I mean? The same thing with the amount of mass. If you have more mass, then you need less speed, obviously. But so you can stack. You can actually stack the vortex on top of each other. I wish I could do a picture of my apparatus right now, but it's on my YouTube channel. You can see all that on my YouTube channel.
So if you had a huge iron ring, you wouldn't have to spin it that fast, and it wouldn't break apart.
A huge.
In theory.
Well, the spin, the tangential speed, that's what matters. The tangential speed is going to be lesser if it's larger. You know what I mean?
So the RPM is more important than the weight.
Well, I'm talking about RPM, but it's really the tangential speed that matters. The tangential speed is gonna, if you have a liquid, it's gonna be different from the inner radius to with the outer radius.
Oh,
Yeah.
right. I get you there.
Yeah.
The differential in the two rings spinning, the outer and inner radius of the fluid.
Exactly. So yeah, but
All
yeah,
about the details, isn't it?
Sorry?
It's all about the details, isn't it?
Yeah, I've been through that already. I did all the maths, and I did what I'm pretty much most happy is the latest Biot-Savart equation that matches exactly the other mainstream equation regarding the amount, the induced magnetic or gravitomagnetic field induced by a gravitoelectric mass in motion, field in motion, sorry. And it's all, most of it is all in my paper. I hope you write it down, or I can post it in the chat. Actually, a link to my paper. But yeah, if you have any other questions, just let me know. Files. PDF. Yeah, it's all in that directory right there. Static finite.pdf. And you can find finite_theory.pdf right there.
Awesome. So I should ask what else you guys have going on. Bill still has his hand up. Bill?
I forgot to mention something that before William asked me questions. The mass is actually a frequency. If you use Einstein's own equation, E equals mc squared and E equals the Planck's constant times frequency, then and you assume the equivalence, you assume that the photon has an equivalent mass, then I know that some people say that photon cannot have mass, so I'm going to use a different term. It has an equivalent mass, so you can conclude that the mass is a frequency. What is a frequency? That's the gravitomagnetic field. So that explains the inertia as well. Inertia. So if the frequency is higher, it's gonna take more energy to make it move. So it's all everything works. The big puzzle works. Sorry about that. I think
Philip?
William.
Philip? Yeah, well, this kind of reminds me of what the work of Bruce De Palma, launching steel balls. You rotate them at 20,000 RPM, and he observed there's a change in the gravitational effect, that they would fall faster.
Yeah.
Okay. And also, with gyroscopes, I like playing with these gyroscopes. So, if you start up a gyroscope, of course, it's going to have this gyro lock to it. Okay. But suppose you took two gyroscopes like this, and then you just glue them together. Okay. And you think of the mass as a spinning mass, right? But with something like this, it seems like the mass is really not inside the disk, it's outside of the disk is the mass. It's like a mass field effect. So that when I go and start this one up, okay, I put two gyros like this together, and then I spin them in opposite directions, okay, such that the angular momentum cancels on this. So I start this one up, and then I'll go and start this one up. And so to me, it's like the mass is on the outside of the spinning disk. So they fall over. There's the gyroscopic action seems to cancel, the angular momentum cancels on this. So it just plops over. So it's like the mass field effect outside of this is what's being interacted with. I don't know if that makes sense at all with this gyroscope, these two gyroscopes, because then you have a zero vector that I spoke about in my lecture. The zero vector cancels out the angular momentum.
The net effect is null. It's just like the pair production when you have a photon that splits into electron and positron.
Those two are
right. Yes,
William. But it's neutral, so it has both charges. It's just the net effect is null.
Right.
It's not really an electron and a positron. It's just that the net charge is null.
But William, what if you spun one horizontal and one vertical? Now what happens?
Well, that's a good question. I don't have that particular setup. I only have
I
only have these two to play with here. But mass appears to be a field
You wouldn't
effect.
be canceling the horizontal spin. If you spun one vertical, you wouldn't be canceling the horizontal. The horizontal force would remain, and now there would be a new force, the vertical. So I guess the horizontal spin is resisting downward with gravity, and the vertical spin would probably push or pull that way.
Yeah, well, if mass is indeed a field effect, you would have one like this, and then one like this. And then the two mass fields would interact with one another. So I thought I'd throw this this monkey wrench out there.
I like that flux transformer design, by the way. That's nice design there.
Mm-hmm.
The triple core, right? 3 cores, right?
Right.
Yeah.
So something to think about, I guess.
Yeah, and also remember that force field is possible because if you alter the time component of any projectile, laser weapons, or nuclear radiation particles, then you block the time. Nothing can go through. So it's really an efficient force field right there. If you control time, you control pretty much everything.
Uh-huh.
Yeah.
Well, the idea is to get time to reverse itself.
If you're in agreement that time and gravity are the same component.
Yeah, that's the thing. Minkowski said that time and gravity are the same thing, but Einstein himself did not really agree with that. It's really two distinct things, but their time is induced by a mass in motion. So the faster a star or planet will rotate, the greater will the time dilation be. The time dilation amplitude will be, but they're together because they're generated. The planet generates time and gravity as well. It creates both, but they're really.
Well, isn't time based off the measurement of the speed of the electron to some degree?
Yeah, but that's a local measurement. That's just I think the time it takes for a particle.
They're using an atomic clock or a cesium clock. I mean, what are they measuring? The decay rate of the cesium?
Yeah, I don't follow the international standards for these definitions, so I can't tell you. But yeah, do you get the general idea of that's a high level idea. I can explain pretty much everything, the whole universe at all scales by assuming graviton, then like the mass in motion induces a time rate, and that graviton and photon is the same thing on a different frequency. So you can search it yourself on Google. You're gonna find a lot of papers that talks about graviton to photon conversion and back and forth, which is a gravitational waves or ELF waves. It's all the same. So yeah. That's all I have to say, and thanks for everybody, and I guess we can move to the next person.
Awesome. Well, Phil, again, thank you, man. Thank you. We did the clapping thing. You were the bomb. So then the question is, who else has stuff to share? Yes.
Yeah. Thanks.
Bill, thank you, man. What about Mark? Let me pick on Mark in his hoodie, his silver hoodie. Mark, what you got going on?
Today we're testing a sample of ceramic material, actually. Been seeing a couple blips right around the 3,500 Gauss mark, which is about where it's expected because we're at 9.88 gigahertz. Gyromagnetic ratio being 28.025 gigahertz of that per Tesla. So that will equal out to about 3,500 Gauss. And I've been jumping around there today.
Maximize the screen.
We saw a couple little blips, and I'm gonna have to dive into the data afterward. One of the issues we've been having with this experiment is that the RF seems to be bouncing off all these materials and not getting absorbed properly, which is why we're switching towards ceramics or very thin film metals to get the RF energy into there. And that's about it. We're also doing working with Victor out of Spain. I met him through the APEC conference, by the way. Great resource. If any of you are working on actual experiments and need help, that just put the word out there. People will come to your aid if you're doing good work. So Victor's going to be helping us out with LabVIEW, and I'm trying to get the data of several different devices into one place to make the outputs more coherent, and we can actually see where those blips are and what they relate to. That's what we're working on right now at the lab.
That's awesome, man. It makes you wonder, maybe those, like with Art's parts and those UFO skin materials, where they're like multiple layers, maybe that's to channel the RF. I think, wasn't that what John Brandenburg was kind of saying about Pace's work?
Yeah, that's possible. Pace's work is also refers to RF and high voltage DC being combined in the inner and outer hulls of the craft in order to create an inertial mass cancellation effect. And that's something that we're looking at as well. That experiment's on the shelf over there, and we got to build it. Jeremiah Pop may be coming down to the lab next month, and stay tuned, and live long and prosper, everyone.
Live long and prosper yourself. Wait a minute. Yeah.
It's like that. No? I thought it was this way.
Great. We just flunked Star Trek. We all flunked except Phil. Phil did good. The rest of us flunked Star Trek. Okay. Well, so who else has stuff? Jeremy G has his hand raised. Jeremy? And do you think you could turn your camera on?
Yes.
There we go.
I saw some. Soon I'll be doing experiments later on, probably within like the next December, or not next December, but this December. I'm just trying to get reading material from MIT and stuff, start studying all that. But I might have an item that might could probably test. Just recently we had a meteorite fall in my area, and somebody got a hold of it, and that would be really good analysis to study that with spectralis analysis, and maybe get some kind of data.
That'd be cool. Yeah,
and see what, like, I'm just surprised that happened just like 2 days ago. So maybe understanding how the radiation, space radiation or whatever affected the what do you call it, the dynamical matrix or wave matrix. You get the plot points and all that, see how that interacts with space, from material science at least. So I'm still a novice in this. So, but I did find something on YouTube or Google, not YouTube, but supposedly they're talking about black holes now, and maybe extrapolating like theoretical science, extrapolate energy from a black hole. Like you can create your miniature black hole, or they've been talking about a lot. But I remember seeing a NASA paper talking about using a wavelength or some small wavelength to actually, like, they successfully maybe activated a black hole or something. It was some paper. So I just kind of want to throw that out there. It was in Google. So I'll be far off on it, spitballing, but if you check the NASA .gov site or whatever, the archives, you might find it. So I'll have to pull it up again. So maybe that, get some cool information about something. So one last thing is the whole John Teeter story. I actually talked, I really don't want to say this, but I actually talked to the guy behind the patent, Martin Pullman, but I'm not going to say too much, but he sent me a letter, and he talked about how it could be feasible to make a time machine device out of that box that you see in the 2004 patent. He said it would require two black holes that he mentioned, and he said something about sinusoidal waveforms, and that's probably like the black hole is a wave matrix, like almost total internal light reflection, right? But it's more like plasma balls or electric, the ball lightning, how it's like, it'd be like a wave resonances, or like total internal light reflection, but with the plasma balls. I think the same analogies with the black hole, just it's more energy condensed. And he was talking about it. So it's kind of weird that there's connections that NASA would mention something now. So I'm just kind of stretching it out there, but it's kind of weird there's similarities, right? Because I just started watching the video on physics of UFOs with Eric Weinstein and Hal Puthoff. I don't know if that's an old one, but they were talking, and then when they mentioned that they shot, it's probably old news, they shot the electron beam on two reflectors, like one that went the other, and there was like another mirror on the other side, and they said they had like a solenoid in the middle, which would produce electric current or something, and that the light would go around. They said that like nothing was supposed to interfere with the electron beam, like, inside the solenoid, right in the middle. I think you might know what I'm talking about, but they said though that there was still interference through the current in the middle with the electron beam. So like it's supposed to be like they said it's supposed to be like a perfect insulator on the inside with energy, but even then, despite being a perfect insulator, they said it still went through and made interference. So that's like
maybe a magnetic field can interfere with an electron beam.
Yeah, but like it's
solenoid
it's like
produces a magnetic field.
Yeah, but it's like dealing with higher, like it's like dealing with stuff with protons or something. I'm just kind of throwing that out there. You know,
They used the solenoid to see if the magnetic field would interfere with the beam. That's why they put the solenoid there, make the magnetic field. And
oh,
see if it would get in, cause the light beam to bend or not. I'm sure it did.
oh yeah, of course. I mean, to me, it's
I
like
mean,
a step down.
you have to have a strong, probably a really strong magnetic field for light beams to bend on.
Yeah, yeah. They said like
your
when
average.
they're talking about space time, I think that like the really interesting, more feasible thing is either time dilation, like something physics around involved with that, like tachyons, like they said, because it's just a wavelength measure with a mass added to it, and that with time dilation or something with just a lot enough energy to actually affect stuff, and I think it's very feasible, very very feasible, even if it's infeasible, because like it's like to me it's all a matter of like tuning process. It's kind of like you have those old tuners like the brain synchronizer back then, because my main research field is biophysics and neuroscience, so it's trying to link like the resonances of the hemispheres and stuff down to like the nanoscale past the DNA within the water. Like, yes, I'm a big void is yin yang promoter with biophotons stuff, but I was thinking about like it was like the original like resonances themselves that you can detect all the way down to the nanoscale or past, and like how you can link them up, But my point is like with the brain synchronizer device, what they said when they synced up the brain resonances with just the synchronizer, and there was like they managed to like make a coupling without any like wirelessly, without any like connection with like any like they didn't have any electrodes on the brain or nothing. And they said the old brain synchronizer back in the 50s that first came out actually synced up with, allegedly claimed actually synced up with the person's hemispheres. In some way, there was like some way they detected it. And so I'm thinking like the old fashioned way of tuning like that might solve the energy problem.
Using inductor coils to pick up brain signals? That's not far.
Well, not just that, like just regular charging tuning, like just like you would, do with the brain synchronizer, but the way you tune something just in general, either be like an electric generator or you're charged like you're trying to get the frequencies aligned. Like I'm still like a complete novice to this, but the way they got the hemispheres resonant locked, or I guess quantum entanglement with the synchronizer, I guess that's what it is. But the way they like tuned it, manually, just like they didn't even really like weren't trying to like I guess measure something, but they were trying to just get the tuning right, to be like a perfect signal, I guess, with no loss. I guess that's what a superconductor is, but but just regular resonance, and then somehow like can increase the resonance, like it's already resonant now, and then they just increase they jack the gain up more than whatever.
Increase the amplitude on the resonant signal.
Yeah. And then I guess there's a way that if you can measure each like joule of energy, just even 1 joule, as far as measuring a joule, you would stop there, increasing it, amplifying it, and then you would fix it to be resonant again, and you just keep doing that over and over and over. It's redundant, but you keep increasing the amplitude of the energy. I guess the amplitude, like you said, more without wasting any joules of energy, if that makes sense. I think that would solve the energy problem in general. It's a weird idea, but it goes into engineering, and I did a lot of like some research on this pretty well. But I'm just throwing some really wild ideas out there that probably are practical and might answer a lot of conspiracy.
You want to look into the Bedini pulse motor to understand how to resolve that.
Yeah, I got information on it.
To recycle not your forward pulse, but to capture the reverse pulse that occurs as a result of your forward pulse. You don't get to recycle your forward pulse. But if you follow what Bedini built, you would be able to capture the reverse pulse that occurs as a result of your forward pulse, which you cannot recycle your forward pulse.
But is your reverse
that gets
pulse
used
the
in the inductor in the process of creating the magnetic field in that inductor? That's where your forward pulse got used up. But when you remove your charge to that inductor, it feeds back.
Yeah.
that's called the
It's
reverse
like
voltage. So that's what the Bedini system does.
is reverse voltage
You want
also
to
standing
replicate that.
waves?
You want to replicate the Bedini SG,
Yeah,
you're
yeah.
gonna just build it and then ask questions later as Bedini
Okay, that's probably
specified.
that would be better. I do
It's
do a
about
lot
the
of
high
research.
voltage diode and which direction it faces. That's a hint I can give you while you're building
Okay.
it, to pay attention to the high volt. There's only one high voltage diode, the 1N4007 diode. There's only two diodes in the circuit. The other one's a low voltage diode. But just pay attention to which way the direction the high voltage diode is facing, and how it's connected to the inductor. And,
Okay. Because like with comparisons with that, I can attach that or compare that as equivalent to the
what I can tell
fundamental.
you is, when you charge the inductor left side is, one side is positive, the other side's
Yes.
negative of this inductor, right? You charge it, right?
Yes.
And let's say the one side that's positive, when you remove the charge, that side becomes a negative. And the same thing happens to the opposite side. Its polarity flips. And if you
Okay.
have a high voltage diode pointing in the right direction, you can dump that reverse polarity that's occurring into a battery, or you can dump it into a coil to create another induction field.
Well, I was trying to say that you would use the same coil and raise its resonant field itself. Like you wouldn't try to transfer any of the energy. Like you would just keep raising that one coil's frequency resonance higher, like a self resonance.
Well,
So
the over unity part doesn't come during the on cycle with the frequency.
Oh.
The frequency is a pulse frequency that's on and off, right?
yeah.
So the over unity is not happening during the on. That's the forward voltage, the on. It's happening during the off,
Yes.
when the circuit's open, and there's no way for your energy to flow in that circuit yet. It's flying back
Yes.
during the off cycle, when your circuit is open and there's no cycle for your energy to flow through. A closed circuit is a circle. When you open that circle, where's your energy going to flow now? Nowhere. But yet
Right.
there's a flow happening in the reverse direction. And that's called the reverse flyback voltage. The Bedini system harnesses that reverse flyback voltage. And it also harnesses your forward voltage to spin the wheel.
That's pretty interesting.
So it spins the wheel with your forward voltage, and it charges a second battery with the reverse voltage, to be specific.
There was something
Once you
similar.
get that going in system and see what's going on there. Once you see what's going on there, you see that essentially the wheel is spinning for free.
Yeah.
I mean, I've experienced zero loss with a wheel spinning. That's the only thing. I didn't have anything tied to that wheel to have a gain. I just had it on a bearing. I didn't tie it to an alternator or nothing. So I didn't experience any gain, but the wheel was definitely spinning, and I didn't lose any power from one battery to the other.
That's good though. That's where you want to get started.
The way he did it.
Yeah. Well, no, I'll try that. Also, I heard that something similar to that with as an open circuit with.
When you're talking frequencies, it's always an on and off going on here with any type of frequency, and it's all this stuff, all this unexplained phenomenon that we're experiencing. That could be called repeatable experiments if you want, science, is happening during the off cycle of this switching events, of all these switching systems.
Well, everything's got a vibration, everything gyrates in a way, or goes, left to right or whichever, everything's got a shaking thing, but you can't really, you can see it with the eyes, but everything does. So, everything when the collisions happen, there's friction, which is heat or whichever, things don't work right at the angles, how I see it.
So far, my understanding is the heat is coming from the forward voltage, and the cold is coming from the reverse directional, the reaction that nature seems to put into these inductors when you remove the power to them.
Yes.
We call it surge power. We throw it out into the ground.
Hey guys,
I feel it as it's at go ahead.
I was just going to ask.
Well-
I got something to share if y'all want to see it.
Yeah.
Sure, I'll go ahead and
Jared, go
keep
for it.
quiet.
Yes, sir.
Yeah.
Minute here to get share screen all set up. Share. There we go. So Ray Stanford, the UFO researcher from last century that did a bunch of work, he ended up sharing this image with me. So in 1978, he had a setup where they were monitoring UFOs with a bunch of magnetic equipment and gravitic equipment. And after they had tracked this event over 2 days, they ended up doing a Fourier transform on all of the readings and came up with this frequency chart for the magnetic and the gravitic readings. And the interesting thing was that you can see that, well, maybe you can't see it. The gravitic readings are the dark black line and the magnetic readings are the light blue line. There's some definite spikes at certain intervals there. So what I did this last week was I ended up figuring out that they were dealing with fractions, whole integers as well as fractions of the golden ratio, which was very interesting. So I spent a good amount of time on this, making sure that I'm not crazy and I'm not seeing numerology type stuff, and the numbers just keep popping out. So down here at the lowest end of 0 to 2 hertz, you get very strong magnetic readings, but you don't get any gravitational readings. I think that's because they're using the golden ratio as one of the main components of the electromagnetic waves they're dealing with. And that when they mix certain ratios of those electromagnetic waves together in just the right ratios of phi, you end up somehow managing to get a gravitational field as well. Some further research suggests that the golden ratio stuff relates to entropy, the rates of entropy. It can increase or decrease the rate of entropy depending on how you're manipulating the golden ratio in your system. Yeah, so that's where I'm at now. I've been hashing out the specific relationships between these spikes, and it's quite fascinating that they'd be using the golden ratio and flying saucers at all. The end.
Oh yeah, I would like to add that if you don't mind. Well, that's weird. I saw something somewhere that there's a conspiracy thing where somebody said phi equals pi. I don't know if that might help with studying about why all of a sudden phi is increasing, is able as a measure, as a good measure, quote unquote, maybe to detect like the entropy, increasing rates and decreasing rates, right? Which is kind of weird. So I'm just throwing it out there. Somebody you might, I guess you could look into who's really likes to claim it, I guess, a lot is what's his name? I can't remember. I forgot his name. Darn it. He always talked about the golden ratio or Fibonacci sequence, and he always talked about pine cones kissing noses. I think you might know who I forget his name. Dan Winter. He talks about it as those are the measures like all of a sudden for being perfect phase conjugation of, the waveforms of which, that's like the perfect measure where they intersect completely. And he's talking about how hydrogen is perfectly becomes another element or something, steps up to hydrogen completely without zero loss using the golden ratio. So you could probably check into that. I mean, some say he's being,
something there.
Yeah, full of something. Yeah, go ahead. I'm sorry.
So in quantum computing, that was another research paper I found, was in quantum computing, they found out late 90s, early 2000s, was that when they took the system and they operated it at Fibonacci number, golden ratio numbers, it's called finary, phi-nary instead of binary. Anyways, when they operated it like that, the decay time for the system jumped way up. Like it went from a 1.5 second decay time to max test they did was 5.5 seconds. So 3.5-fold increase on the amount of entropy that was entering, or 3.5-fold decrease on the amount of entropy that was entering the system to cause the system's wave function to collapse. Some other stuff suggests specifically that the quantum states at the edges of materials can be affected when you're operating under this golden ratio regime.
Yeah, that's weird.
It's wild.
And I want to add to that because that's where it leads into information physics as maybe being the actual final well, it's progenitor is like before, so I forget the word for after, but it could be that could be the answer for proven information physics. Go ahead.
Yeah, so I looked at the information side of things because I love looking at the universe through the information theory lens. And
it's awesome. Yeah,
I just you know what, Jared, I just saw another paper on entropy and information theory. I'm going to drop this link in here. Let me find it in my history.
Jared, what would you call the opposite of entropy?
Neg entropy.
I got it, but go ahead.
When you have entropy that is reducing over time, it's called neg entropy.
Oh, you got it.
Wouldn't it be called explosive force?
No. It's called neg entropy. It's scientific term. It's already well established.
Yeah,
when the system becomes more complex over time, rather
really
than
big on this too. So in his paper,
what's an analogy for entropy? Is not implosion. Is not entropy.
Implosion is a form of
entropy
and energy release, right? So if you have energy,
it's inward energy. It's inward energy. Implosion. Not outward energy, and inward energy. Implosion, explosion.
Implosion.
Entropy is implosion.
It's all about the point of view that you have, the perspective that you have, right? So if you're looking outwards, it's an implosion. If you're at the center of that, it's coming into you, right? So now you have all this. If you're at the very center, you have all this energy coming in. That would be neg entropy. If you're on the outside, you're watching all this energy in a given space reduce, right? Well, I shouldn't say reduced energy in space, but you get the idea that the surface area of this energy is getting smaller. And so from your external observer, you have entropy. From the internal observer, you have neg entropy.
But both are implosive.
They
forces.
can be. Sure. I think so.
Sure. Going back to that information theory thing that I was.
Oh, go ahead. I was going to add more too.
So you have binary, where instead of ones and zeros, you have 0.618 and 1.618, right? So that's called finary. It turns out there is an even better version of this, which instead of being a binary form using phi, it's a ternary form using phi. And that looks like it is not the best, but way better than finary as far as information density.
Yes, that's really neat. Like, what do you think it'd increase if they do urinary to added with the finary? You know, urinary is like the 4th version, like ternary is like 3, or urinary or quaternary. Yeah, do you think it'd increase?
Urinary, binary, ternary, quaternary.
Quaternary, yeah. Do you think it'd increase if they do it, add finary to the next?
No, so the universe has this wonderful method behind its madness. It looks like it operates in 8-dimensional space, or it uses 8-dimensional building blocks, I should say, and it usually uses 3 of them. So each one of these 3 8-dimensional building blocks are like a trit, or one of these 3 ternary bits, right? A trit. So when you have these 3 8-dimensional objects and you build them in different certain configurations, now you're starting to get particle generation, you're starting to get force generation. You get all of the key elements of the universe from the 8-dimensional things. Those 8-dimensional things are built off of 2 4-dimensional things, which are built off of 2 2-dimensional things.
Well, I think if you keep doubling the dimensions like that, doubling each one, it gives you more information. So really, it's just, to me, it's a wave matrix.
It maxes at 24 so far as we found. So when you look at information theory,
sounds like a fractal building process.
Yes.
It actually does have a fractal underpinning to it, but so far for information theory, the way they determine how efficient a code is they take spheres, and they see how well can these spheres pack together with as little space in between them as possible. That's the gist of it, right? But when you get above 3 dimensions, it gets a little confusing, so you got to do lots of matrices. So the smart mathematicians have done these matrices. They figured out which dimensions are the most efficient. 8 dimensions is like perfect. You can't get more perfect than 8, except that at 24, another special thing happens. So in 8 dimensions, when you go from the 7th dimension to the 8th dimension, the space in between the spheres has increased enough that a whole nother sphere can pack in there now all of a sudden. And then that happens again at the 24th dimension. And when you get that extra space, that's where your information, your code gets whole other aspects to it, right? It's this generative complexity type thing. It's quite fantastic that the universe looks like it operates based upon these principles. That now that I'm getting obsessed with phi this last week, I wouldn't be surprised if there was some similarity between the perfect code that is used to generate the universe and ternary phi. Fernary.
Yeah. Well, I'm trying to add chaos theory to physics in some way, and that's really been interesting because it's been like the 1970s. Chaos theory started to pick up really heavily and was incorporated into physics with fractals and all that. So it gets really in depth. Like Wolfram is a really good book to read on that. But I mean, I'm just making connections. But what I wanted to add about the entropic rate, about phi. I find a YouTube video online that proved a hypothesis of mine, maybe. I don't know if it was Versatasian, I don't think it was him, but one of the people ignited aluminum, or I think it was burning aluminum or tin, and they put it on a measuring device, like a weight scale or something that's very sensitive. And they wanted to see if something that was burning up with a lot of friction, entropy, I guess, just wild, random, become heavier. And it proved it. They weighed it first, and then they set it on fire. And apparently the sucker got a lot heavier a little bit. I'm like,
that was because it was absorbing oxygen during the combustion, and that added oxygen added weight to the whole thing.
Yeah. But would that be would anything with a lot of friction in it?
It's going to blow projectiles upward and push it down on the scale. That would
in the video, they even acknowledged that it was because it had not just consumed external oxygen, but the oxygen bonded to it because it had oxidized, and that added oxygen mass to the material.
The weight didn't occur during the flames going upwards.
Well, is there a way to test other ways to test if friction can increase something's weight? But maybe other type of experiments. I guess to try to prove friction increases weight. Yeah, friction increases weight. Something like the resonance.
It also seems to be the primary driver for heat.
Yeah. Okay, a lot of atomic collisions not colliding right inside the object is creating weight. That friction type of friction, atomic collisions, inaccurate atomic collisions. Yeah.
Hold up. Go on the eBay page for the Amazons. You might even be able to find it for free online, but find any college physics textbook, any college physics textbook. In the first 3 or 4 chapters, they're going to talk about friction. Learn a lot about what's going on with friction and how it controls the things around it. I highly recommend looking into that. It's super straightforward. I don't really know about how you're going to be increasing the mass of the thing with friction, other than if there was an insane amount of friction, like an explosion, where the energy density has somehow increased enough that you're warping space-time. But if you're doing that, if you're warping space-time, your energy levels are so extremely high that you're not going to be able to be present in that area very easily.
But would those high energy levels though have a lot of mass to them though? I mean,
well, remember mass and energy are the same thing, right? So the energy that goes off when you take a 1 megaton bomb if you take all of that energy of a 1 megaton
Yeah.
bomb and you funnel it all inwards into like, you know, a little grape-sized spot, the amount of energy there is going to have a certain amount of mass. And if you did that out in space, right, you're going to have, for a split second, you're going to have stuff wanting to orbit it, because that energy released that somehow is also contained is going to deform space-time enough that something's trajectory is going to get curved.
That's interesting, though. Jeremy Reese and Mark and them did tell one of the scientists they put a lot of compression, and I guess there was a lot of mass being maybe put in this one spot, but they managed maybe to warp space-time just a bit. I saw a weird optical lensing effect in the one spot. They said they were taking these resonators, or I think they're resonators, they're like these iron blocks or something, but they were all putting pressure in this one spot. So I mass, they said, does bend stuff in a way. So I'm not trying to make these correlations or, you know, connections with other things that are, you know, abstract. But
If anybody's interested in a flyback circuit, let me know.
Mike, have you ever built a Marx generator, or has anybody on the call ever built a Marx generator?
Can you describe it?
You charge up a bank of capacitors in parallel, and then you discharge them in series. And by doing that, you're able to step up the voltage extremely high. So depending on how big the capacitors are and how much charge they can hold.
I've heard of this before. What did you call it again? Marx?
It's called a Marx generator, M-A-R-X.
Never built one, but I've heard of it.
It looks super straightforward to build. You can buy them online for like $100 or $200, but the ones you buy
switch
online,
them series, charge them parallel.
Yep. And when you buy the ones online, though, they're usually only good for like 100 kilovolts, and I'm looking at trying to get one that can do more like 1,000 kilovolts.
What's controlling the switching on the series?
It has spark gaps, so when you short two of those electrodes together, right, you get that little spark.
The air is doing your frequency.
So once that sparks, then the next one up the chain, all that energy gets released, and so it over voltages it, so then it closes that circuit, and then it just keeps doing that. And each time it closes the circuit, those sparks are getting stronger and stronger and stronger until up at the very end, it's releasing.
The parallel circuit or the?
It's a series and parallel circuit.
Which one closes over and over, the parallel or the series?
Mark knows about it.
So basically, it gets charged in parallel, and there's a bunch of resistors, and then there's spark gaps that are set up to discharge it in series. And when it's discharging in series, the resistors are still there. They suck up a small amount of the energy, but most of the energy goes, toward, as he said, in stages, and eventually builds up to your final voltage. One thing, though, that we've seen with the high-speed camera when running our Marx generator over here is that it actually fires from both sides. So right behind me here is a 1,000,000-volt Marx generator. It actually fires from the top down towards the center and from the bottom up towards the center simultaneously. Just like lightning comes up.
Sounds like something fun to build, I'll tell you that.
Just like lightning comes up from the ground and down from the cloud simultaneously. It does the same thing.
Do you think the act of the two of the arc, the electric field from that arc, affects the next gap next to it?
Increases the voltage for sure.
Well, I'm just thinking if they're coming like this.
Yeah, not only that, it seems to be coming from both sides simultaneously. So you'll see it firing at the very top stage and at the very bottom stage, but not in the center stages. And then it moves in towards the center. And this happens extremely quickly. You need to have a very high speed camera in order to see this.
Like, how fast was your camera going to be able to see it?
300,000 frames a second to see it.
And it was like a couple frames?
It was one frame.
Oh, jeez.
You mind me asking how much a camera like that costs?
One frame where you saw some of them firing at the top and at the bottom, but not in the center.
Jeez. I think it's like a $150,000 camera, Mike.
No, it's
No?
the newer ones are like $150,000 to $200,000. This one is like 7 years old, so it's quite a bit cheaper than that.
Didn't they have those kind of cameras during the 90s or 1990? Like, no.
No, I don't. Maybe. This one is made by what's the name of the company? It's the V711 Phantom V711 is the one we have. So 7 refers to 7 gigabytes of image transferring power per second, and the 11 is the 11 gigabytes of high speed image data collection. So that would be like a second and a half of whatever the highest speed you want to set it at. The highest speed that they have right now, I think, is 75 gigabytes per second throughput, and that would be like a $200,000 camera.
Damn, it's pretty good.
Yeah, but they're both able to. Even the older ones are capable of up to like 1 million frames per second, but you lose a lot of pixels. So it'll only be like 3 by 15 pixels or something like that.
Speaking of which, Mark, your zoom is cutting out a little bit. Looks like it's doing a square out of your zoom. Oop, there he goes. Oh, okay.
Oh, is that better?
No, it's still there. Mark, do you think that I could make you the host, sir?
I have to leave. I have to leave right now. Kids.
I wonder if I could make Jarod the host. I have the same problem. I have a 14-year-old saying, pick me up. I'm like, working, kid. So
No, I'm getting ready to go out to dinner with the wife here.
Oh, okay. Well, maybe we should keep things. Do you guys want to close things down at 7:30, or should we keep things going until around 8? Or what's the plan? It's kind of slower tonight, but I don't think that's bad. More mellow. People are more. I hear more discussion, which is awesome.
Yeah, I mean, I'm willing to keep going if anybody else is. Like, I just got on, so it's up to
I'm
you.
out. Yeah, I think I'm out too.
Good talk, Jarod.
Yeah, I mean, we got a couple of folks still with us. Mark, what time are you peeling out?
I was going to peel out in the next like 10 minutes or so. Jim
Okay.
Marshall was talking about the Ivo quantum drive.
Jim?
Hello.
Sir, do you want to give us a rundown on the Ivo drive?
No, I was asking if anybody knows about it. I looked
know
it up.
about it. Yeah, I know about it.
I briefly talked.
Patent.
I've heard of
It's
it.
supposed to go up this month, supposedly, or in November.
That I don't know. I know they were going to
Going
launch
in
March.
December.
SpaceX transporter flight.
The transporter flight's scheduled for December.
Yeah, from the website, there's this pastor dude who was working on transmitting power, and he came across some sort of quantum drive, and Drew thinks it's related to his patent.
Drew knows it's related to his patent because his nonsense came out 2 weeks after the international patent published.
It's supposed to be able to generate like 10 millinewtons of inertial thrusts, they claim.
Yeah, and 45 pounds of metal. It's basically, if you go and look at our patent and look up, we have a version of it's like a comb and a flat plate, or just basically a flexible surface on a flat plate. It's our flat plate thruster that we developed about 4 years ago. They simply jumped our patent, produced it on a large scale, and threw it up. They're going to throw it up on a SpaceX launch.
So you think it just uses like the Biefeld-Brown effect, but they call it quantum drive?
No, it uses asymmetrical electrostatic pressure.
Isn't that the Biefeld-Brown effect?
It is.
No. No, is it really?
It is, yes.
Okay, sure.
The Tim, you built one of those, what, 10 years ago, 15 years ago?
I don't know. I don't really think it's the
Talking about Tim
Biefeld-Brown effect.
Ventura's.
The Biefeld-Brown effect is a asymmetric capacitor. It has nothing to do with lifters, by the way. The asymmetric capacitor, and he discovered that it produces thrust, and that in a vacuum it worked even better. And apparently, most of his research was made top secret. It's not part of the patent, but there's Jeremiah, I think, got some of his notes and stuff. They took the parallel plate capacitor research pretty far, and apparently part of the lore is that T.T. Brown was also involved in the Philadelphia project.
Yeah, now you're talking my language with that. So interested in that.
Well, I don't know. All I know is that they are operating at about 1/10 of 1% of the efficiency, and I'm operating at around 62.5% efficiency. So
Yeah, but if they can prove it can work in a hard vacuum, that would be good.
I've already got, dude,
Because everybody says it's just
every day.
Everybody just says it's ion wind, right?
Literally, I have a warp engine running in my shop right now for like the last year and a half.
And it's not ion wind.
Of course it's not ion wind. I operated at 3 times 10 to the -6 torr.
And how much thrust?
To date, I've made about 5 millinewtons.
Great.
But I'm not actually trying to make a massive amount of thrust. I'm going for efficiency. And at the moment, I'm down to making, well, I'm at 62.5% efficiency. It can lift 62.5% of its mass against gravity, which puts
David Perez
Mars landing in
like,
target.
Yeah, David Perez's device made about 5 or 6 newtons, not millinewtons, full newtons. That's using, I think, like 1,000 or 1,500 watts of RF energy.
Can you make that same amount of thrust or newtons with less wattage or less mega or wattage in general?
Well, I've seen them use flyback drivers to use, do these asymmetrical, devices that levitate. You drive it with the reverse flyback voltage. It's a high voltage radiant spike.
Yeah, that's probably
works excellent off that voltage.
I think efficiency is what everybody should be going for, like he's saying.
These devices are literally running off the off cycle of a pulse.
Yes.
Yeah, well, you're not going to get much more efficient than microwatts per millinewton.
Well,
which is the realm I'm in.
Well, I got a book I just got now from about electrostatics from MIT and stuff, and someone tried to learn about it. It sounds cool though. No, it's not. I'm experimenting with antennas because there's a personal thing with using antennas to power something, and I don't know, just getting in the realm of that. That's kind of neat. But that's kind of like the project I'm kind of working on. Something to do with like antennas and brained diodes, or like the like an EEG cap similar. But I'm trying to come up with some kind of weird deal. It's kind of like an ad hoc process, I've read something online called ad hoc wiring or transistor wiring or something. I don't know. It was an article. It's kind of interesting. It's some weird similar thing that they would use resonance frequency to boost brain waves using the laptop, but they would have like some like an external gain with an antenna or something. I don't know. It was this weird thing I was checking out. But there's some of those weird connections. I know it sounds weird, but I'm checking it out. Like I said, I'm a complete novice of this, but I'm trying to do a weird approach on something. But it seems to be coming together.
Jeremy, what kind of antennas are you working with?
Just any antenna right now. I mean, like just starting out. I wouldn't know where to really start. I mean, you got parabolic dishes. You got your regular the ones that you would do like a TV, how they have at a house. I have Delta T antennas or around those. And but like I said, I'm just getting new to this. So I'm trying to learn as a different approach than standard academia. I'm trying to kind of just experiment, in a raw sense. Like you still need your mainstream physics and everything. I'm still going that route, but I'm trying to like maybe intuitively try to gather material in a way and intuitively learn just like a raw experience. Maybe I might.
What do you get when you put two parabolic antennas together?
You get a higher gain, right?
You get a flying saucer.
Oh,
that's what they are.
Oh, wow. Huh. Well, I was thinking something more than just flying saucers. Like my interest is the human body and how to couple the resonances of the different tissues more correctly together. Where the resonances would be more.
Did you see that silver hoodie that I was wearing before?
It's been a long time.
I'm talking about in the last half hour, not a long time.
No. I just got
yes.
in. Right,
oh, okay. So that I'm wearing that to avoid the resonances of RF hitting the human body because they can cause a lot of damage.
Damn it! I know. I'm very well aware of that.
That's what these tinfoil.
There's good resonant frequencies and there's bad resonant frequencies. Well, not bad. They're just bad for
too much energy and they hit at the wrong angles. But I got a textbook I got from MIT or a bunch of material related to it called The Fundamentals of Tissue Resonance. So I'm getting really heavily into this. And I remember you sent me that one math textbook that was in Garda or in Garda, I think. Last time I was on here. I don't know if you remember, Mark. I can't remember the name of it, but his last name was Engarta, like ENGR, ERTA. But yeah, like the book I got for Fundamentals of Tissue Resonance is like that in depth as well. It's pretty complex, so it must be something good. And
you might want to look up this Japanese billionaire. He built a light for his wife who had skin cancer, made from fiber optic cable that went up to the roof and attached to a solar collecting lens, and then it sent the sunlight through the fiber cables down to another lens that projected the light. And he said that the fiber optic cables purified all the sunlight, took out all the bad rays in the sunlight. So out came only pure light. And his wife was pointing the light on one plant on her counter for like 5 minutes a day or whatever.
Yeah.
Just grow like crazy off that light.
And
her skin cancer was healed up too.
Yeah, there was the same. Yeah, that's photobiomodulation. I was telling Jeremiah about that. How you can use the laser.
Yeah, you have to filter out the bad rays in the natural sunlight. There's stars out there that are called dwarf stars.
Yeah.
And they emit the most pristine form of light, which is capable of enhancing DNA and all sorts of things.
Sounds like light codes. That must be the light codes.
The pure light is what enhances DNA. So if a star with pure light ever passes by your planet, it will probably do that, make you guys smarter.
Well, that's what I'm doing. That's the same experiment I do with the neuroscience. That's what I do with the jellies. But you don't have to have pure light. You just have to have the right frequencies to hit at the right angles. You know, the right angular momentum.
The Kachina topic, it might make a little sense there.
Like, I'm really getting down like the technical details with this, you know, with using math and stuff. So I'm starting back from pure basics. If I have to go back to, you know, what I say, at least before algebra 1, at least, you know, and then start from there again, and then, you know, learning. So, you know,
A good goal is would be to replicate a dwarf starlight.
well, yeah, but you would need to know the signal.
Amazing if you could do
that the dwarf starlight would go at, the frequency the dwarf starlight would go at, and see if you can replicate that with the same amount of, like, I guess, power, but with, you know, efficiency. And it's like you said, you're probably not going to get more
dwarf star is actually
efficient.
a dying star, so it's doesn't really put out a lot of power.
Oh, well,
it's just running at a very, it's just at some kind of a resonance, you know.
Yeah, but like I said, it comes down to the frequency, though. It really just comes down to the frequency itself, you know, because it's really what the key is. You know, frequency determines the power and the gain and everything, and the angle. So it's really why I say you don't really need the light itself, the pure light. You just need the frequency of it, or something, you know, understanding frequencies in general to, you know, hit things at the right angle. I know I'm reiterating it, but you could use that with low powered frequencies, you know, even like at 9 hertz, and say something's resonating at or vibrating at, I say vibrating, yeah, so if something's vibrating at 969.03 hertz or something, if you could get the correct opposite polarity, you know, the opposite reverse of the 9.69, you know, gigahertz, and you can somehow, you know, send a signal that's like 9 hertz at that opposite polarity, you know, of the top one, you would have instantly, you know, have no I guess you won't use any wattage, you know, or any joules of energy. Perfect gain, you know, with zero loss. If you could do it like that, you would probably instantly cure the body of all its ailments, you know, just depending on the tissue. But I know different tissues vibrate at different things, but you become like a capacitor. I think that's, you know, you that's how I see it. So, and that's what I'm trying to draw a lot of similarities to things. It gets pretty interesting what you think about it.
Yeah, and let's stay a little bit careful on the medical stuff, because that gets
oh yeah, that's right.
Yeah, I try and stay away from that. Just stuff like that, it gets YouTube banned. So
yeah, okay, we'll just talk about devices and just like in general with generators and anti-gravity stuff. Go ahead. Anybody got anything to add?
I mean, it seems like things are winding down. We can keep going till 8, I think, or it's up to you guys, unless you have anything more to share. Mark, what are your thoughts? There's Lulu. Lulu is asking to share. Lulu, what do you got? Lulu is mute. Lulu, you're not muted, but I can't hear you. That's I think maybe your mic is turned off. You have audio. If
anybody wants to see a Bedini circuit, I did a modification of this thing.
By the way, Michael, how does it feel to be in the holodeck?
Well, we can try, Lulu, no worries. We can try again, or if you want to pop on out.
I actually bought a green screen just to make it look better. Okay. Green cloth or whatever.
Yeah. I wouldn't make a pizza appear in front of me right now.
I think we're pretty mellow right now. Everybody's kind of winding down for the fall. Do you guys get that feeling? I kind of get that feeling. Things are kind of slow a little bit right now for the fall.
Yeah. Well, for me, it's like I got an intelligence increase. I don't know, like during the summer, I felt like very hazy or something. And then all of a sudden, like when things cooled down, I got like a lot of memories back. Like I remember like 2 years ago from the discussions we had. So
it could just be the heat slowing you down. It could just be.
It's probably it. I mean,
yeah.
Shoot, that makes a lot of sense. They said there was a study somewhere. Avoid. Well, maybe that'd be for offline. But yeah. Anyways, like what interests me though is at least is the tachyon thing that one guy talked about. Has anybody have any reference to any like tachyon devices that maybe have been hinted at or some type of paper? Besides the introduction he did.
I've seen several papers written about it, but they're all heavily prefaced under the if tachyons are real, this is kind of a hypothetical approach.
Yeah.
And so
Can you hear me now?
Yeah, now I can hear you, Lulu.
Okay.
Okay. All right. The Nobel Prize in Physics of 2023, they measured the attosecond. The physicist Anne L. Hulier. I don't know if you guys read about it, but it's kind of cool.
I have not. Do you want to drop a link?
Yeah, I got the article on that. I saw that. I said,
okay. Well, she uses a method where she creates like kinetic energy by flipping an infrared light. The wave motion of the infrared light. She, and traps the electron in a state of like yo-yo, where it creates like a lot of kinetic energy. So every time the electron hits the orbit back into the atom, it releases a light, and that is called the attosecond. It's an amazing process.
Interesting. Here is I will put an article in. It may not be as detailed. Well, thank you, Lulu. That's thoughtful. Oops. Everyone in meeting. There we go. Here is a link I just found.
Probably got a lot of references to other studies, supporting it, so that it would be helpful to check those out too.
Yeah, my focus is on the flyback. Again, everybody to understand that is the entropy that everybody's talking about. When an inductor is, pushing back with a, AC current, you first give a coil and a winding that AC is going to push back in the opposite direction that you're going with your AC. And it does that initially. But if you keep your AC connected, and eventually it goes with your AC. So in a sense, AC power does not take very much advantage of creating multiple cycles of this pushback, whereas DC does, and that's entropy. That's the entropy cycle happening in the pulse.
Which is the loss.
It's in the off cycle of the pulse, not the on cycle. The on cycle is the explosive force, your energy from the battery or whatever, your generator, your forward energy. And there's this thing that they say Einstein came up with the term of, for every action, there's an equal opposite reaction. I happen to think that's Tesla, based on the wording.
Yes.
Because Tesla worked with inductors, and these inductors are, they're kicking back in the opposite direction.
Yes.
Not only with constant alternating current of plus and minus, or whatever, plus alternating current is not really a minus. They just call it a minus. It's just two positives, one higher positive, one lower positive, up and down like that, creating a wave of two positives, one greater, one lesser. But DC is not two positives, or a positive and a negative like we call AC. DC is a DC pulse is an on and an off. A DC constant current is an on, nothing but an on.
Yes.
So
but every time
entropy
you
doesn't happen on the on cycle.
You don't?
No, and
Not
the only
easy?
reason with AC you see entropy happening in the very first connection to the inductor with AC, you get this pushback initially, but then it goes forward with your AC after a few seconds. The reason you see that pushback, because you just created an on cycle briefly, and then when it dipped down, to a lower potential, the AC, and the negative side of the AC dip down to a lower potential. Right there at the first half cycle of the lower potential, the kickback took advantage of that and said, hey, let me push back. I see a lower potential coming in. But instead with DC pulses, we go on, potential on, potential off. And all of a sudden in the potential off cycle, we get all kinds of entropy coming in super high voltages with a very narrow band and very little energy, but a lot of voltage. And that's how they pump up these capacitors to high voltage. Or they do it with the reverse flyback of an inductor. They don't, you give an inductor 12 volts in one direction, it's going to give you 12 volts in that direction. But when it comes in the other direction, it's up in the, hundreds of volts. But your amperage disappears. It gets converted automatically somehow. Your amps goes away in exchange for volts, higher volts. Your 12 volts and whatever amps, the amps got sacrificed to turn it into high volts and low amps on the reverse direction with the DC pulse. So that's the Bedini is capturing that high voltage spike on the reverse flow of that inductor and sending it into the other battery. It's a little confusing. I tell you, man, I built this Bedini thing, watched them run for 3 years, and I didn't get what was going on until
No, I just got to
fourth
keep
year.
hacking at it, Just got to keep going at it. It's with everything,
But if you focus on this reverse flyback effect, it'll start to come clear.
I could probably
what's going
Google
on here.
that. I could probably Google that and maybe dig something up related. I'm pretty sure
Yeah, it's all in the off cycle. It's all happening
Yeah.
in the off cycle. All this
Well, it's
entropy
probably-
that people are capturing in
Kurt,
circuits or
so
whatever.
Curtis just arrived, just to let you guys know. So Curtis will be presenting on October 28th, and I got a couple other folks lined up. I got to get the calendar. Actually, I have everything set up except the calendar invite for the studio. I need to do that. I'll get on that next week, and I'm going to start working ahead for November 25th. I think that Jack Sarfati is actually going to make it on that day, and we have a couple other potential people. And then December, we're scheduled for December 23rd, but we may bump that schedule a little bit. And maybe we'll just do something super casual, or maybe we'll do something fun. You guys want to wear Santa hats? Have Santa APEC? Look at Mark. Mark's really?
Hey, can we do Hanukkah too? Hanukkah APEC. What about Hanukkah?
Do they make wait a minute, they don't make Hanukkah hats. Sokol, quit trying to confuse me. I'm smart enough to know that.
We'll have just the menorah then.
Do they have Hanukkah hats?
Or are you guys gonna do Thanksgiving as well, or are you gonna wear the Thanksgiving hat, or it's like a?
You know what?
Josh Rising says he's gonna wear a Santa hat.
When is Thanksgiving?
Yeah, you wear the one with the brown cap, or it's kind of similar like to.
Oh, that's right. It's always the fourth Thursday of the month, right? It's the last Thursday of the month.
Thursday of the month.
2 weeks ago in Canada.
We wear a Halloween costume for Halloween on the 28th. Maybe that could be cool.
Okay, to remedy this, business owners complained that something less time to shop for Christmas. To remedy this, Congress passed a law in 1941 that officially made Thanksgiving the fourth Thursday of every November in the US. Canada just had their Thanksgiving.
Yeah.
So, but Canadian Thanksgiving is actually kind of like Columbus Day for us, which we no longer celebrate, I think.
No,
I think it's
which is
Indigenous
interesting.
Peoples Day.
It was
Actually, Columbus, if you read about the history of Columbus, I understand why. That's one of the ones that's hard to disagree with. So
yeah,
sad, but
Philippe, you can drive your MHD fluid with the reverse flyback pulse instead of the forward pulse. Use the flyback pulse to drive the fluid.
Oh, speaking of cool stuff, I think even though Jeremy Reese told me about Edgar
DC,
Fouché,
right? Constant current. forward DC.
Yeah, so reverse pulse. It's
But the problem is the pulse is a problem for you, right? Having a pulse. Right?
Well, right now I'm using DC, very simple DC. Sergio was using AC, actually AC, but he was using a coil, so the current will alternate, but the coil would generating a magnetic field would alternate as well, so it would compensate back and forth, so it would go in the same direction.
So you have a coil driving the fluid, correct?
That was Sergio. Me, I'm using DC.
But the coil is driving, your signal is going through the coil to drive the fluid, right?
No, I'm using a neodymium magnet, so I'm not using a coil to generate the.
So you're not using power to drive the fluid?
Yeah, I'm using a power supply for that, stabilized power supply, something like that. Normalized, or I forgot the name. I'm using that and magnet, so because you need electric current and magnetic field to generate a Lorentz force.
Where's your electromagnetic field that's driving the spin? Where's it coming from?
Yeah, that's what I'm saying. You have the magnetic field and the current, the electric current.
What's generating the magnetic field for the spin? What device?
Neodymium magnets.
Just the magnet?
Yeah, but it's still 3 Teslas. It's greater than a coil. Coil creates much lesser magnetic.
Your magnets are stationary?
Yeah, they're permanent magnets.
How does that create spin in the fluid, though?
It's a Lorentz force.
Oh, you're just using the two fields to pull them both. Okay.
Yeah.
That's crazy. So you're going by the so you have to amplify the magnetic field basically of the magnet to get your speed up there, huh?
Well, I was thinking of amplifying the current using capacitors, because the magnetic field is pretty strong. 3 Teslas is pretty strong already.
Okay.
So I was thinking of increasing the current instead. I can't do that with capacitors.
Increasing the current to what? You said you didn't have any inductors here. What are you increasing the current to?
I was thinking of going up to 1,000 amps.
What's consuming the current?
What do you mean?
You must have a coil in there somewhere consuming this current. You telling me the magnet is consuming the current?
No, I have the gallium and the.
He's running it through the liquid.
The current's going through the fluid.
Yeah. Yeah.
And then there's a magnet on the side of it, right, Phil?
On the top and the bottom, on the side, it's a ring of zirconium.
And you're just feeding the current straight through the fluid, is what you're saying.
Yeah,
I got you.
Yeah, and guys, we're at about the 10-minute mark. I'm going to close things down at 8 if that is okay with everybody. And that way we can get all of our child pickups and fun stuff like that done for the evening.
Yeah.
Yeah, sorry, Michael, I was not precise. But you just watch my YouTube.
Why can't you use an inductor to spin the fluid instead of actually spinning it with the sending current through the actual fluid?
No, it's both. Yeah. So what he's doing is, if I understand this correctly, it's basic Lorentz force, right? And you've got to have basically 2 magnetic fields. One of them is from the current, and you just run the current through the fluid, and then the other one is from a permanent magnet that the fluid is mounted near, flowing through.
Yeah,
this is basic Lorentz force.
Why do you have to run the current through the fluid to get it to spin? You can't use EMF to get it to spin alone without putting the current through it? Just like a coil around the device creating EMF fields in a circle? Why do you have to send current through the fluid to do it? You don't necessarily have to put the current through the fluid to get the spin. You could just use coils around the thing, and then you can.
That's the definition of the Lorentz force. You need a current and a magnetic field. And
you have to have 2 magnetic fields, but I get what Mike is saying. You could structure.
I'm just saying you got more play when you can spin it without sending current through the actual fluid.
Can I just step in here for a second and explain this? Okay, so what Phil is working with is different than just a simplified MHD. So in order to have a magnetohydrodynamic drive, you need two things: a really powerful magnetic field and a conductive liquid that you flow current through.
Yeah.
Or a conductive medium. It could be, air you can consider as your conductive medium if you have a voltage high enough. But anyways, what Phil is looking for is the third component that emerges when these two field components are simultaneously present and interacting with each other. And this third field component can be identified within Phil's matrix as gravitomagnetism. And it's been known by many different names, but it is an emergent field component that comes from the Lorentz transform, which is the Lorentz force plus the relativistic transformation based on the difference in the velocity of the charged particles moving through different parts of the system. And so this third emergent force can be vectored because it's going to be shifted 90 degrees to the direction of the charged particle motion through the liquid. So in order for Phil to do what he's trying to do, he can't just simply spin the gallium, because it's not about just simply spinning the metal mass. It also helps tremendously to have the current flowing through so that you have the orthogonal electric field within the fluid itself, which is going to polarize it as it passes through and spins through the magnetic flux of the fixed or stationary stator magnet.
So this is more than just about mass, then, spinning mass.
Yeah.
This is more complicated than just spinning mass.
There's already the effective mass. That just having any mass spinning at all, any mass whatsoever, is going to produce this type of gravitomagnetic field. But in order to generate a vector force from the gravitomagnetic field, you also need a cross product from an electric field flowing orthogonally. So in one, you can just get a modification of the local space-time, and it's sort of an omnidirectional effect. And in the other case, you can use the omnidirectional distortion to amplify one of the field components that you're trying to work on, either the magnetic field component or the electric field component.
Yeah, see, and my thought was, what Mike was saying was, and I could be incorrect about this, but my thought was he was saying you could induce the current rather than using like a DC, which you probably could, right?
No, I was saying instead of sending an electrical current through the fluid, just move the fluid with electromagnetic fields without sending any current through the fluid.
Yeah. Oh.
But Jeremiah just explained that you need the current to flow through the fluid, I guess orthogonally, which is the opposite direction that the fluid is actually spinning, which
right.
can be
so in this case,
if you're sending current, you can send current.
Right. In this case, in order for Phil to do what he's doing right now, if you were to induce the same amount of current that he's actually passing through the gallium right now, he would it wouldn't relate to the RPMs. In order to produce let me rephrase this. In order to produce the same strength of the magnetic flux that he is currently able to generate in the size of the machine that he has, he would have to have a supercooled coil, or he would have to have a coil that was physically 10 times larger than the magnet that's inside there. And so in his case, he has a DC magnetic field, or a permanent magnetic field. So he can't induce rotation into the gallium and also receive the cross product for the electric field at the same time, unless he simultaneously induces the electric field from another set of field coils on the outside. And that makes the entire setup incredibly complicated, instead of what he did, which is dramatically simpler, which is an inner electrode and an outer electrode with gallium between them, and then a big ass ring magnet.
Would the simple version work just as well if I guess you did something more minute process or something? Like,
what do you mean the simple? You mean is there an advantage to doing it one way or the other? The advantage to doing it the way that Mike is talking about is that you can have a completely sealed vessel with no electrodes in it whatsoever.
Isolation.
And you don't have to deal with the the fact that you need electrical contacts made especially.
Just like a transformer isolates two coils,
Right. Yeah. Right. The difficulty in that is, in order to receive that one nice benefit of isolation, it requires a design that is tremendously heavier and more complicated, with phase controllers and amplifiers and everything else, none of which Phil needs in his current test setup.
Yes.
But apparently having that isolation with the current in the fluid
Well, having the
lose an
isolation
advantage
just simply
of
allows you
the,
to reach higher numbers, like a lot higher numbers.
I agree
Because
with
you
you.
have a different number of choices in vessels that you can use, because you don't have to worry about the electrodes again. And so you could use things like a purely ceramic vessel that's heavily reinforced and highly polished inside wall, instead of having to use some of these other machine parts.
Yeah,
But
something
my
that's like a
question
good
is there a
insulator material.
disadvantage? My question, going back to my question, which was not answered, is there a disadvantage to not using the current through the fluid as well? And I believe there is, because the current going through the fluid is going in the opposite direction that the fluid is actually spinning.
Yeah, the disadvantage to not directly putting current through the fluid is, well, one, you're not going to your scalar product is going to be very controlled with the current flowing through the fluid. So I guess the disadvantage to not using that technique and inducing directly would be, one, it's way more difficult to induce instead of flow, and two, you introduce the problem of phase control, which adds lots of extra added complexity. So disadvantages would be complexity and just overall implementation. It's not necessarily worse, it's just way harder and it's heavier.
Yeah,
Right,
but the advantage is that you wouldn't need extra stuff like current or anything. That would be one advantage.
Well, you'd still need to induce the equivalent.
I would say there will also be an advantage, because if you're using an inductor field to propel the liquid, you don't have to use the forward field of that inductor. You can use the reverse field of that inductor. And also you can use the reverse current of that inductor if you want to send current through the fluid.
Yeah.
And that would be cold current.
Well, guys, I think we
If
are
it's
at
current
the
at
top.
all. I mean, there's definitely high voltage there. But,
I guess the last thing I'll mention, hopefully this permanent magnet electromagnetic gyroscope system should be pretty interesting here. I just threw one together. I spent the last day building it. So I got two little rotors on it, and the configuration is specifically looking for this third emergent field that Harold had discovered and nobody's paying attention to yet, but they will soon enough. But
on that note, why don't we close things down for this evening? We are at the top of the hour. This has been a 4-hour run. Jeremiah, maybe you could tell us, I mean, next time around, maybe you give us updates on this.
Well, I was trying to actually get it done so I could demo it today, but I did get it assembled and it's operational right now, but it's not producing anywhere near the force that I was expecting. So I got to call the guy back who just called me, the inventor of this idea, and I want to talk with him about this design and why it's maybe not generating the same degree of forces. Okay. I guess I need to know about the RPM curve and the nonlinear response of RPMs in relationship to the force.
Well, on that note, guys, I am going to close things down for this evening. It has been wonderful. This has been APEC for October 14th, 2023. Open mic. Have a great evening, guys.
Take it easy.
Thank you.